Hello there. Tonight we journey to the quietest edge of imagination, the place where sky dissolves into infinite velvet, where the stars hum softly to anyone who listens. You rest beneath them, eyes half closed. As the boundaries between your thoughts and the heavens begin to blur, you feel that familiar pull toward wonder, but also a deep, unhurried calm. The air around you feels still, like the breath before sleep. You probably wouldn't notice this if you walked past it, the faint vibration of the atmosphere, the gentle curvature of the planet beneath your feet, but it's always there, quietly reminding you that you are already part of something cosmic. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you'd like, tell me where in the world you're listening from and what time it is there. Now, dim the lights. You begin to drift. At first, you sense the faint glow of the horizon fading. The last traces of city light slip away, and the darkness becomes a soft, enveloping presence. As you rise, the blue of the sky deepens into midnight. The familiar outlines of clouds dissolve into thin shadows until there is only the curve of earth below a marble, swirling with white veils and ocean blues. Above you stretches the true color of the cosmos, not black, but the deepest possible blue, lit by countless points of ancient light. Each star you see is not merely a pinprick, it is a furnace of unimaginable scale. The nearest, the sun, glows just 93 million miles away, though its light feels close, warm, and alive. It takes 8 minutes for those rays to reach you, a blink of time, compared to the years light from other stars travels to arrive here. Some of the starlight you see tonight began its journey before the first humans ever spoke. It crosses millennia, silently carrying stories that no one has yet translated. The air thins until there is no sound but your own heartbeat, steady and calm. You pass the thin boundary where the atmosphere ends, where the aurora still flickers green at the poles. Astronauts say that if you look down from this height, you can see the boundary of night and day sweeping across continents, a slow-moving shadow painting half the world in darkness, half in gold. You are above weather, above noise, above all but the steady hum of your own mind. Scientists call this boundary the Kármán line, roughly 100 kilometers above the surface. It is the place where flight yields to orbit, where wings stop working and freefall begins. Here, there is no up or down, only direction, only motion. You drift effortlessly, your body suspended between the pull of gravity and the quiet rhythm of inertia. You might imagine that space is completely empty, but it isn't. There are stray atoms, just a few in every cubic meter, drifting endlessly. There are streams of radiation, particles, and faint whispers of magnetic fields linking planets to stars. Even the vacuum hums with quantum fluctuations, tiny sparks of existence blinking in and out, so small you couldn't catch one, even if you tried. Scientists still wonder whether this invisible seething is what gives rise to everything, whether space itself might be alive with possibility. As you glide farther, the Earth grows smaller, its colors blending into the dark. From this distance, borders vanish, languages dissolve, and the noise of history fades to silence. You realize how delicate the planet truly is, a pale orb wrapped in a film of air, thinner than a soap bubble. That thin layer holds every breath ever taken, every bird's flight, every storm. And now, from here, it looks like the most fragile miracle in existence. Your eyes adjust to the broader dark. The stars multiply, filling the void like grains of silver dust. Between them are stretches of velvet blackness, yet even that darkness glows faintly with the light of distant galaxies. Each one contains billions of suns, spinning together in spirals and ellipses. You float among them, as though inside an endless ocean. Astronomers estimate there are more than 2 trillion galaxies in the observable universe. Each galaxy holds hundreds of billions of stars, and each star might have planets circling it, moons around those planets, and perhaps life gazing up, wondering just as you do now. When you think of this, your thoughts grow quieter. The mind becomes weightless in proportion to the vastness of what it tries to grasp. You notice how still everything seems. If you were to shout here, there'd be no echo, no vibration of air to carry your words. Yet silence itself feels full, as if filled by the hum of distance. You sense that space is not empty, it's potential in its purest form. A curious fact, even here, your body glows faintly in infrared light, invisible to your eyes but real to any sensor tuned to it. Every living thing radiates warmth into the cold, as though quietly insisting, "I exist." Astronauts say that when they close their eyes in darkness, they sometimes see flashes, tiny sparks, caused by cosmic rays hitting the retina. It's as if the universe occasionally taps you on the shoulder to remind you it's there. Scientists still debate how far this universe extends. The observable part is limited by the age of light itself, around 46 billion light-years in every direction. But beyond that, no one knows. It could curve back upon itself like the surface of a sphere, or stretch infinitely with no edge at all. Some suggest space might be shaped like a dodecahedron, repeating in a pattern so vast we'd never see the repetition. Others imagine that beyond what we see are realms disconnected from ours entirely. The mind, like gravity, bends under the weight of such thought. You let these questions drift through you, not to answer them, but to feel their texture. They're soft things, like clouds of curiosity. The longer you float, the calmer you become. The stars above no longer seem unreachable. They're simply part of the same quiet rhythm as your breathing. You turn slowly, noticing how the sun lights one edge of Earth in gold. Somewhere below, oceans reflect that light, and waves move in patterns that mirror the spirals of galaxies. Everything echoes everything. The same forces that spin the Milky Way draw tides across the shore. The same carbon that fuels your cells was once part of an exploding star. You begin to understand that drifting into the cosmic sea is not an escape from reality, it is a return to it. Every atom in you once belonged to this sky. You're not apart from the universe. You are what it's doing, right now, in the form of awareness, breathing, and wonder. Your pulse slows, the stars blur softly. You feel yourself settle into the rhythm of space. Stillness, expansion, silence. You float, content, listening to the distant shimmer of creation. And somewhere, far below, the world keeps turning, gently, beautifully, as it always has. You drift farther now, leaving even the faint gravity of Earth behind. The pull that once tethered you fades to almost nothing, and in its absence, you begin to understand the strange weight of emptiness. Here, in the dark, there's no up, no down, only the endless stretch of space. The stars seem fixed, but you know they're racing away from you at impossible speeds. Everything is in motion, and yet you feel still suspended in a sea of invisible forces. The weight of nothing. It sounds paradoxical, but out here, nothingness has structure. It pushes, pulls, and shapes everything we know. Between galaxies, space is not a void but a fabric, a smooth, elastic sheet that curves and twists under the weight of matter. Einstein called it space-time, and he taught us that gravity isn't a pull at all, but the way this cosmic fabric bends. When you rest near a planet, you're simply following that curvature. You're falling along the folds of space itself. You close your eyes, and for a moment, you imagine that fabric. You picture it like a soft silk sheet, rippling under invisible weights. Planets make gentle dimples, stars make deeper ones, and black holes pierce it entirely. If you dropped a marble here, if such a thing could exist, it would never stop rolling. It would orbit endlessly, tracing those dimples forever. A faint hum seems to fill your mind, like the sound of distance itself. You realize it's not sound at all. It's vibration, the gentle trembling of everything that exists. Quantum physicists say even empty space teems with fleeting energy. Virtual particles appear and vanish, exchanging momentum before disappearing again. You can almost imagine them, tiny blinks of creation happening everywhere, all the time. Scientists still wonder whether these fluctuations are responsible for something profound, the birth of universes, the slow expansion of space, or perhaps the mysterious dark energy that drives galaxies apart. To them, nothing is never truly nothing. It's the restless potential for everything. You move through this invisible ocean and feel its quiet influence. Your motion, your path, even your sense of time, everything bends subtly under its laws. Gravity, though weak here, still whispers. A single grain of cosmic dust would drift toward you if given enough years. You realize that nothing in the universe ever truly stands alone. Even the most distant particle is connected, pulled, or influenced by something else. In the far reaches of interstellar space, there's only a handful of atoms in every cubic meter. Yet those lonely atoms carry the memory of stars. Most are hydrogen ancient, unbroken since the dawn of time. Some contain heavier elements, fragments of suns that lived and died long before your world even formed. If you could gather them together, their story would tell the entire history of the cosmos in whispers. You pass through a faint trail of interplanetary dust. It glitters as sunlight touches it, tiny specks flashing silver, gold, and crimson. Each mote is smaller than a grain of sand, but older than any mountain. Some of it might have once been part of comets, chipped off as they sailed near the Sunday. Some might be fragments from the birth of the solar system itself. It's strange to think that your planet, oceans, and body all come from this same material dust floating in the dark. Every element heavier than helium was forged in the hearts of dying stars. When those stars exploded, they seeded space with the ingredients of life: carbon, oxygen, nitrogen, iron. You are literally made of the universe's debris, assembled by chance and time. You turn your gaze toward a faint light far away, the sun, now a soft white coin against a field of black. Around it, invisible but real, stretches the heliosphere, a vast bubble of solar wind. It's made of charged particles that flow outward in all directions, forming an invisible boundary between your solar system and interstellar space. The edge of that bubble lies billions of kilometers away. It's where NASA's Voyager probes now drift, carrying small gold records etched with greetings from Earth. Somewhere, even now, those records sail through silence, waiting for an audience that may never come. A quirky detail: those records include sounds of waves, wind, and human laughter, tiny fragments of home sent into the void. One day, long after the sun fades, they may still wander, carrying traces of life long gone. In that sense, nothingness becomes a keeper of memory, a space where the echoes of existence endure. You feel how fragile distance is. Light from the sun takes more than 5 hours to reach Pluto, and over 4 years to reach the nearest star. And yet, the space in between is not idle. It is alive with radiation, with streams of particles, with fields of magnetism that twist and dance like invisible auroras. You think about how astronauts describe the sensation of floating. They say it feels both freeing and humbling. Without gravity, your inner ear loses its bearings, and your body forgets the direction of down. You drift, and in that drifting, you realize how much of human life depends on the quiet insistence of gravity. It keeps oceans in place, holds air to the planet, and shapes your every step. And yet, here, its absence feels like a kind of peace. If you could speak now, your voice wouldn't carry. Sound needs air to move, and there's none here. Still, you can imagine what it would sound like: slow, steady, resonant. Perhaps that's what the cosmos is doing on another scale, vibrating in silence, its frequencies too vast for human senses. A thought lingers. If space curves under mass, and time bends with it, does that mean every breath you take changes the universe just a little? Scientists say yes, in theory. Every gram of matter, every bit of energy, tugs on the cosmic fabric, altering its shape by the smallest imaginable degree. You are part of the equation. The cosmos is not something you look at from outside. It is something you belong to, something that notices you back. Your eyes wander again. In the deep distance, faint stars pulse softly, their light filtered through the thin haze of cosmic dust. Some of those stars no longer exist. Their light is a memory, traveling alone through billions of years. It's a reminder that the universe's truest stories are told not in presence, but in persistence. You drift, and the silence deepens. There's comfort in knowing that nothingness is not empty but balanced. The pull of gravity and the push of expansion keep everything in motion, like a slow, cosmic breath. You are floating in that breath now, weightless, timeless, surrounded by the vast weight of nothing. You close your eyes and let the universe hold you, as it always has. Somewhere far below, the faint blue planet continues to spin, and above, the stars shimmer like patient, glowing thoughts. You breathe, and the cosmos breathes with you. You open your eyes again, and the first thing you notice is light. Not the sunlight you know, but a gentler, more ancient kind. A soft scattering that fills the space between the stars. It doesn't shine from one direction. It surrounds you, subtle as breath. Out here, light has no boundaries. It flows endlessly, touching worlds you will never see, carrying stories you'll never quite finish reading. You drift through it slowly, and you begin to understand. Everything you see, everything you will ever see, is because of light. It is the language of the universe, the only messenger fast enough to cross eternity. Every color, every glimmer, every spark of wonder in the night sky is simply light speaking across distance. A photon leaves a star, and millions of years later, it finds your eyes. You become the last stop on its journey, the final surface it touches before it vanishes into memory. You blink, and in that instant, you've caught a message that began before the earth was even formed. That's what makes light so astonishing. It's not just illumination, it's communication. If you could slow light down to human speed, it would tell you things: how stars live, what elements they're made of, how fast they're moving away. Astronomers use this cosmic language like detectives, reading an invisible code. Every wavelength reveals something different. Red tells of warmth and distance, blue of heat and nearness. In between, the rainbow becomes a kind of fingerprint, unique to each celestial body. You can almost see it now, the delicate spectrum stretched out in front of you. You glide through colors: violet, indigo, green, gold, each humming softly with its own frequency. You notice how light is both particle and wave, behaving as though it can't make up its mind. Scientists still wonder what that truly means. Is light something that is, or something that happens? Is it a messenger, or the message itself? Your thoughts drift to the quirks of its journey. In a vacuum, light travels at a perfect, unwavering speed about 300,000 kilometers per second. Nothing outruns it, yet it's oddly fragile. A single dust grain can scatter it. A passing cloud can soften it. When it touches water or glass, it bends, slowing just enough to shimmer. Every sunset, every prism, every shimmer on the ocean's surface is light deciding to dance. You pass through a field of starlight scattered by ancient dust. The glow looks like mist, but it's not. It's countless photons bouncing from one particle to another. The effect is called interstellar reddening. The farther the light travels, the redder it becomes, its energy stretched thin by distance. That's why faraway galaxies look warm and golden, like embers of a fading fire. It's not that they burn red, it's that the universe itself is gently pulling their light apart. A curious thing about light: it always moves at the same speed, no matter where you are or how fast you travel. It doesn't care about your frame of reference. Einstein realized this simple truth changed everything. It meant that time and space must bend to preserve that speed. The faster you move, the slower your clock ticks, all to keep light's pace constant. The universe sacrifices time itself to protect light's purity. You notice how still you feel, yet every photon racing past you marks time differently. For light, there is no waiting, no duration. From its own perspective, a photon born in the heart of a star reaches your eye in an instant. It experiences no journey at all. In a strange way, light is timeless. It simply exists everywhere along its path. You glance toward a distant star. Its light began traveling before humans could dream. It's possible that star has already died, its fire extinguished, and yet its glow continues to reach you faithfully. You're seeing its past, not its present. That's one of light's quiet miracles. It turns space into a museum of time. Every star is a relic, every beam a memory. Scientists sometimes call this the look-back time. When you gaze into the deep sky, you're not looking outward, you're looking backward. The Hubble and James Webb telescopes do this too, catching light that's been traveling for billions of years. The earliest galaxies they photograph existed when the universe was only a few 100 million years old. You realize that looking up is also looking into the past, into the first flicker of everything. And yet, for all its brilliance, light can be deceiving. It bends around massive objects, a phenomenon called gravitational lensing. When light passes near something heavy, like a galaxy cluster or black hole, space-time curves and redirects it. You might see the same object appear twice, or stretched into a perfect circle called an Einstein ring. The universe plays tricks on your eyes, bending its own language into art. A soft wave of luminescence passes through your vision. It's not a real object, but the faint glow of the cosmic background light, the leftover illumination of countless dead stars, all blending into one invisible radiance. Even when stars vanish, their photons remain, drifting endlessly. In that sense, light is a form of immortality. You remember something astronauts say, that when you stare into the blackness of space, it's not really black. It's full of color, deep blues, soft violets, even faint reds so subtle the eye can barely detect them. True darkness doesn't exist. There's always some photon finding its way through. There's another strange fact. The darkest part of the night sky, between stars, glows faintly in microwave light. It's the residue of the Big Bang, stretched over time. Invisible to your eyes but detectable to instruments, it's called the cosmic microwave background. Every inch of space carries it, a quiet reminder of the universe's first light. Scientists still wonder whether light might hold more secrets. Could it carry hidden dimensions? Could it reveal why matter and antimatter didn't annihilate each other completely? Some theorists suggest there might be forms of light we can't yet detect, rippling through invisible parts of the spectrum. Others think photons might eventually decay, though no one has seen it happen. For now, light continues, graceful and constant. You drift through it as though swimming through a living current. It wraps softly around you, brushing your skin, filling the silence with invisible motion. You realize you've never truly been in darkness. Even when your eyes close, photons pass through you, countless and kind. You think of home, of sunlight through leaves, of reflections in water. Those too are cosmic stories told in miniature. The light warming your face on Earth once burned in the sun's core for thousands of years before escaping into space, then took just 8 minutes to cross the void. It arrives unchanged, carrying warmth across emptiness, simply so you can see, breathe, and remember. You smile softly. The universe has been speaking to you in light your entire life, and tonight, you finally listen. The language needs no translation. It just asks you to notice how beautifully it travels. You float deeper into the dark, following the slow bend of space itself. Out here, distance feels different. The farther you drift, the slower everything seems to move. Light, time, even thought. You start to feel that time itself isn't something that passes, but something you drift through, like a soft current. Time stretches here. You can feel it not as a ticking or a pulse, but as a quiet elasticity, like silk being drawn between invisible hands. Near a massive object, it stretches even more. Einstein taught us that time and space are not separate, they are woven together. A star's gravity doesn't just hold planets in orbit, it also slows their clocks ever so slightly. You think of an astronaut orbiting near a black hole. For them, a minute might pass, while years slip by elsewhere. Time behaves like light. It bends under weight. The stronger the gravity, the slower the flow. You imagine standing near a neutron star, watching the universe speed up around you while your own heartbeat stays unchanged. It's hard to grasp, but comforting somehow. The cosmos moves at many tempos, yet all are real. You remember the famous experiment with 2 atomic clocks, one kept on Earth, one flown around the world aboard a jet. When they were reunited, the airborne clock had lost a fraction of a second. It was proof that motion itself distorts time. You can't feel it, but every step, every orbit, subtly changes your relationship with the future. Scientists call this time dilation. It's one of the universe's quiet tricks. The faster you go, the slower you age. A person traveling near the speed of light could, in theory, experience only a few years while centuries pass on Earth. For them, the stars ahead might appear frozen, stretched by motion. You can almost imagine it racing among constellations while history flows by like a river below. And yet, the strange thing about time is that you can never quite hold it. You can measure it, describe it, even feel it, but it always slips through your grasp. It's as though time doesn't exist in the universe, but the universe exists in time. You drift within that paradox now, neither rushing nor still. Around you, starlight bends slightly, curved by invisible hands. You're watching gravity sculpt time's surface. Einstein's equations describe it perfectly. Space curves where mass resides, and time flows differently in those curves. Every planet, every star, every galaxy carries its own rhythm of duration. To live anywhere is to live in a specific beat of the cosmic clock. You glance toward a distant red star, its light flickering softly through the dark. It's a supergiant, older, heavier, slower. Its immense gravity bends space-time so deeply that even the light leaving it must climb out, losing energy, shifting red as it escapes. The star glows like a warm coal, its time moving just a little slower than yours. You're both part of the same song, just at different tempos. Closer to you, the faint glow of the Milky Way curves across the darkness, like a ribbon of fog. Every star within it follows the galaxy's slow rotation, taking more than 200 million years to complete one orbit. The Sun has circled the Milky Way about 20 times since its birth. On that scale, human history becomes the blink of an eye so brief that, cosmically, it might as well be a heartbeat. A curious fact: scientists think that time itself began about 13.8 billion years ago, with the Big Bang. Before that, the concept of before may not even make sense. There was no ticking, no change, no sequence, only potential. Space and time were born together, expanding from a single instant into the endless continuum you drift through now. You wonder, if time had a texture, what it would feel like. Perhaps smooth and endless in deep space, rippling slightly where gravity pulls at it. Or maybe it feels like sound, a vibration through which everything resonates. The ticking of atoms, the pulse of stars, the orbit of planets, all instruments in a single cosmic rhythm. Astronomers have found ways to listen to time itself, through pulsars, dead stars that spin with perfect regularity, emitting radio waves like cosmic metronomes. Some spin hundreds of times per second, their timing so precise they rival atomic clocks. If a planet passes near one, its gravity changes that timing ever so slightly, allowing scientists to detect worlds they can't see. You picture those pulses flickering in the distance, a slow, steady heartbeat echoing across light years. There's something soothing about that idea. Even the dead have rhythm. Stars that collapsed long ago still mark the seconds for an entire galaxy. You float in the silence and feel that pulse, faint but steady. You begin to notice time in everything, the rise and fall of light, the shimmer of dust, the steady hum of your own breath. Scientists still wonder whether time truly flows, or if everything past, present, and future already exists simultaneously. Some theories suggest the universe is like a block of crystal, every moment frozen in four-dimensional geometry. To you, it feels like motion, but that's only because consciousness slides through those layers one by one, like a needle tracing a record. The music isn't being made, it's being revealed. You breathe softly, thinking of all the moments already written: the formation of stars, the birth of planets, the first spark of life, the far-off ending of suns. All of it exists somewhere in the structure of time, waiting to be seen. Perhaps you, too, are both happening and already complete. Your eyes wander again, and you notice a distant quasar, a brilliant, ancient galaxy core blazing brighter than 1 trillion suns. Its light began its journey billions of years ago, when time itself was young. The photons that reach you now are older than your species, older than your world. When they left their source, Earth was nothing but stardust, swirling in potential. And yet, here they are, arriving perfectly on cue. It makes you wonder whether time is as linear as it feels. Could the universe replay its own moments, or does it move in circles too vast to comprehend? Some physicists suspect that deep in quantum mechanics, time might occasionally loop or branch, creating infinite versions of each event. If so, then perhaps somewhere, another you is watching another sky, asking these same questions, drifting through the same eternal stillness. You let that thought settle, not as a worry but as a kind of comfort. In the grand scale of things, every moment is both fleeting and infinite. The stars will fade, galaxies will stretch apart, yet the memory of their light will linger, woven into the fabric of time. You glance down, though down no longer means anything. Somewhere far below, Earth continues its orbit, one more beat in the vast metronome of the cosmos. Seasons turn, tides rise and fall, atoms vibrate all in rhythm. You realize that even your heartbeat is part of that rhythm. It's a small but faithful echo of the same pulse that moves through galaxies and nebulae. And as you float there, surrounded by light and silence, you feel the truth of it settle deep inside. Time is not an enemy, nor a countdown. It's the soft current carrying you forward through wonder. You are floating through it now, effortlessly, endlessly, one with the unfolding of the stars. You drift farther, and the silence around you begins to take on a strange kind of rhythm. It's not sound, not really, but there's a sensation, a vibration deep within the fabric of space. It feels as though the universe is humming, every planet, star, and atom contributing to a cosmic symphony so vast that your human senses can only imagine it. You float within that harmony, the music of the spheres, the soundless song that has played since time began. If you could translate the movement of planets into notes, they would form chords, slow, deep tones that shift with the passing of centuries. The ancients once believed that the heavens produced literal music as the celestial bodies moved. It was a poetic mistake, but also a beautiful intuition. Today, scientists know that stars and planets do produce vibrations, ripples in light, in plasma, in gravity that can be turned into sound. You listen inwardly and imagine it. The deep thrumming of Jupiter's magnetosphere, the clicking rhythmic beat of pulsars, spinning hundreds of times a second, the soft, crackling hiss of cosmic radiation filling every gap of silence. You are surrounded by an orchestra that never ends. Each object is a musician, each vibration a note. When astronomers record the oscillations of stars, small fluctuations in their brightness, they can translate them into audible tones. The sun, for example, rings like a giant bell, its surface rippling with pressure waves. If you could hear it, the sound would be far below human hearing, like the deepest bass note imaginable. Yet, in those vibrations, scientists learn the sun's secrets, its temperature, its composition, even its age. You imagine standing on the surface of a neutron star. The crust beneath your feet would be so dense that a teaspoon of it would weigh billions of tons. If you struck the surface, the vibration would echo through the entire star in less than a millisecond, a single sharp tone that would ring through space as gravitational waves. Those waves would travel outward, stretching and squeezing the very fabric of space-time as they passed. In 2015, scientists detected those waves for the first time, tiny distortions in space-time caused by two black holes colliding a billion years ago. The signal lasted less than a second, a faint chirp in the noise, but it was the sound of the universe speaking in its own language. You think of that, a momentary pulse that began before life on Earth, crossing cosmic distance just to whisper, "I happened." It's humbling, isn't it? The universe does not need to speak loudly. It hums quietly, and that is enough. You continue to float through the galaxy, and you begin to notice patterns everywhere. The orbits of planets form rhythms. The flashes of pulsars create beats. Even the expansion of the universe follows tempo, a slow, accelerating crescendo that's been building since the Big Bang. It's not music made for ears, but for awareness itself. A quirky fact: some astronomers actually compose with data from space. They convert the frequencies of pulsars and the spectra of stars into musical notes, blending science and art into something eerily beautiful. The Milky Way becomes a melody, Jupiter a bass line, and quasars high, distant bells. When you listen, it feels less like invention and more like discovery, as if they've uncovered a score that was already written. You realize that you too are part of this symphony. Your heartbeat is another rhythm, your breath another wave. Even your atoms vibrate, their energy resonating with the same physical laws that make stars sing. The carbon, oxygen, and iron within you hum quietly, obeying the quantum rules that govern all matter. You are, quite literally, made of vibration. Scientists still wonder if this universal resonance might explain more than we think. Some theories suggest that particles are not points, but tiny strings vibrating at specific frequencies. In that model string theory, everything that exists is a different note in the grand composition of reality. You can almost feel it now, every molecule around you humming its own identity into being. You float past a small pulsar, its beams of radiation flashing like a lighthouse. It spins so quickly that each rotation marks a millisecond. If you could hear it, it would sound like a rapid, mechanical drum. These cosmic metronomes are so precise that astronomers use them to measure time itself far more accurately than atomic clocks. The music of the universe is not chaotic, it is mathematical, consistent, and profoundly ordered. And yet, there is improvisation too. Stars flare and fade, comets swing in wide, eccentric orbits, and nebulae shift their colors as they scatter starlight. The melody changes endlessly, expanding and evolving. If creation has a soundtrack, this must be it, endless variation on a theme of motion and stillness. You find comfort in that thought. Every heartbeat on earth, every raindrop, every breath is a tiny echo of that cosmic rhythm. You realize that sound itself, so familiar, so human, is just vibration, slowed down enough for us to feel. The universe vibrates at every scale, from the trembling of atoms to the undulation of galaxies. We are surrounded by waves, immersed in music, whether we hear it or not. You begin to imagine what silence really is. Out here, there is no air to carry sound, yet the universe is far from mute. Silence, you realize, is not the absence of sound, but the fullness of stillness. It's where every vibration originates, the calm before every note, the moment before creation begins again. You close your eyes and imagine the first sound ever made, the soft expansion of the Big Bang itself. Not an explosion, but a swelling, a breath. As the universe expanded, it created pressure waves that rippled through its hot plasma. Those waves, those ancient vibrations, still echo faintly in the cosmic microwave background today. The universe's first music still hums around you, invisible but eternal. Scientists can map those waves, turning them into visual symphonies of color. Each ripple marks a fluctuation that would one day become galaxies, stars, and planets. You realize that even the place you call home was once a vibration, a note in the song of creation. You breathe, and for a moment, you feel in tune with it all. The music isn't something you listen to, it's something you are. Every cell, every thought, every sigh is part of the same melody that guides the stars. You drift quietly, letting the rhythm carry you. The pulse of the universe slows to match your own, or maybe it's the other way around. The stars shimmer like 1,000 tuning forks struck at once, and you can almost hear them, a low, resonant tone that feels more like memory than sound. And as you float there, surrounded by light and silence, you understand why the ancients imagined the heavens as a song, because in truth, that's what they are. A lullaby for anyone willing to listen, a reminder that even in the vastness of space, there is harmony. You drift gently onward, the stars thinning into softer clusters until the darkness ahead is painted with faint, glowing clouds. They look fragile, almost transparent, their colors blending like watercolor spilled into infinity: rose, violet, turquoise, and gold. You recognize what you're seeing: a nebula, a stellar nursery, a place where stars are born from silence. The light is so diffuse that it seems to move when you blink. Every shimmer is starlight filtering through dust. Every hue, the result of atoms excited into glow. You float through this mist slowly, and it feels like walking through the breath of the universe itself. You can almost taste it: metallic, thin, ancient. Nebulae are strange places, both violent and tender. They form when massive stars die and scatter their outer layers into space. What remains is a cloud, vast and cool, stretching for light years, drifting for millions of years, before gathering itself again into new suns. You're surrounded now by the ghosts of old stars and the seeds of new ones. It's a cycle without an end, a kind of cosmic reincarnation. You glide past a region where the light deepens into crimson. It's hydrogen, the most abundant element in the universe, glowing softly as ultraviolet light from nearby young stars energizes it. This process, called recombination, creates the rich reds of emission nebulae, the same shade that colors the Orion Nebula you might have seen from Earth on a clear winter night. There's something mesmerizing about it, like watching a slow-motion sunrise that never ends. You move deeper, and the light shifts from red to blue. That's reflection dust scattering starlight, just as Earth's sky does during the day. The particles are tiny, smaller than smoke, and yet they scatter light across trillions of kilometers. You realize that every blue glow is a tiny echo of home, a reminder that the same physics holds across all worlds. A curious fact, some nebulae glow green, not because of any pigment, but because of oxygen atoms. In these clouds, oxygen ions emit light when they recombine with electrons, producing a color once thought impossible in space. For decades, astronomers didn't believe it could exist. They called it the forbidden line. But there it is, softly shining before you, proof that even in vacuum, the universe finds ways to surprise. You drift toward a dense knot of gas, where something extraordinary is happening. Gravity has begun its patient work. Dust and gas swirl together, collapsing inward, warming as they fall. Somewhere within that knot, a protostar is forming a new sun in its infancy. It hasn't ignited yet, but it's close. The pressure and temperature at its core are rising with every second, until soon hydrogen will fuse into helium, and light will bloom from the darkness once again. It's strange to think that every star, no matter how mighty, began like this, an invisible spark inside a quiet cloud. You can feel the slow rhythm of creation all around you, like a breath drawn in before the first cry of life. Scientists call these regions molecular clouds because they contain the building blocks of complex chemistry, hydrogen molecules, carbon compounds, even traces of water. In some nebulae, amino acids, basic ingredients of life, have been detected drifting freely. You float through a soup of potential, a cosmic nursery, where both stars and the seeds of biology are born together. You imagine this same process happening across the galaxy, countless clouds condensing, flaring, dying, and beginning again. The universe, it seems, never stops making and unmaking itself. As you pass through the haze, you notice the temperature dropping. Out here, between stars, it can fall to just a few degrees above absolute zero. The atoms move slowly, almost frozen in place, waiting for gravity to gather them again. And yet, even here, there's motion, microscopic turbulence, faint magnetic fields, shock waves from distant explosions stirring the dust like ripples in a vast pond. A faint ripple moves through the cloud. It's the echo of a supernova shock front, an ancient wave of energy that once blasted through this region, compressing gas and triggering new star formation. It's a reminder that destruction and creation are inseparable. When a star dies, it scatters the elements of life. When its remnants collide with gas, new suns awaken. Every sunrise on every world owes its light to a death that came before it. You catch sight of a bright tendril ahead, a thin wisp of light curling like smoke. That's an emission filament, glowing where radiation from young stars hits denser gas. Astronomers often name such formations: the Horsehead Nebula, the Pillars of Creation, the Veil. They see shapes in the chaos, just as people have always done when gazing at clouds. You look at one now, and imagine it resembles a hand, outstretched as if offering you the universe itself. And then you notice something else, a tiny star flickering through the haze. Around it spins a disk of dust, wide and thin, like a ring of mist. It's a protoplanetary disk, where worlds are being born. The grains of dust collide, stick together, and grow, forming pebbles, rocks, and eventually entire planets. It's a process that takes millions of years, but to you, floating here, it feels timeless. You wonder which elements from this nebula will one day form mountains, oceans, or even something alive. Somewhere in these particles might be the atoms that will someday make eyes to look back at the stars. The thought feels both intimate and infinite. Scientists still wonder how precisely the first spark of fusion ignites, how the balance of temperature, pressure, and turbulence suddenly tips and a star comes alive. The math describes it, but not the moment. Perhaps that's part of the mystery that keeps us looking up, knowing that even with all our equations, there are still miracles too subtle to measure. A soft shimmer surrounds you now, the faint fluorescence of ionized gas, glowing like moonlight through fog. You reach out, though your hand meets nothing solid. You're floating in light, in possibility. Every atom that touches you is ancient, older than your planet, older than your species. You breathe, and though there's no air, you feel as though the nebula itself breathes with you. You glance back, and the cloud seems endless. Its edges dissolve into darkness where stars wink like distant embers. Somewhere far behind, one of those stars might already be sending its first light into the universe. It will shine for billions of years, nurturing worlds, anchoring orbits, and perhaps someday, lighting a sky where someone else looks up in wonder. You smile softly. The nebula's glow fades behind you as you drift onward, but you know it's still there, still whispering light into the void, still singing its slow, radiant song of birth and renewal. And in that song, you hear a reflection of yourself, quiet, luminous, alive. You float away from the glowing clouds, and as the nebula fades behind you, the starlight sharpens once again. The airless silence feels denser now, filled not with mist, but with clarity. All around you, stars glimmer, each one alive in its own right, a self-contained fire burning across time. You drift among them, slow as a thought, and realize you are witnessing billions of small suns, each with its own destiny. You approach one distant but dazzling. It swells before you, a perfect sphere of golden light. Its surface boils and churns like a living thing. Here, you witness the secret life of stars. The sun, you know, is one among many, a middle-aged, average star, but to see it closely would be to see violence hidden inside beauty. The surface, called the photosphere, is a dance of storms and flame, with temperatures nearing 6,000 degrees Celsius. Beneath it, heat rises from the core, where nuclear fusion turns hydrogen into helium. Every second, hundreds of millions of tons of matter vanish into energy, released as light and warmth that spill across billions of kilometers. You feel the heat. Though it cannot reach you directly, it vibrates through space, soft and relentless, a glow that has been steady for nearly 5 billion years. That steadiness, its calm, is an illusion of vastness. In truth, the star's surface is in constant turmoil, granules of plasma rising and sinking, waves of magnetism arcing thousands of kilometers high before snapping in flashes of ultraviolet fire. Yet somehow, all this chaos produces balance. Stars are the universe's forges. They create everything heavier than helium. In their cores, fusion binds protons together, forming new elements: carbon, oxygen, nitrogen, iron. These elements drift outward through stellar winds, spreading the material of life itself. You are watching the slow alchemy that built you. You move closer, and the star's light becomes a flood. It pulses subtly, expanding and contracting with a rhythm like breathing. Some stars pulse predictably, known as Cepheid variables. Their changes in brightness are so regular that astronomers use them as cosmic clocks to measure distance across galaxies. Each heartbeat of a Cepheid tells how far away it lies, its light a metronome for the universe. A curious fact: the largest stars, called blue giants, burn their fuel so furiously that they live only a few million years, brief, brilliant lives, compared to the billions of years of smaller stars like the Sunday. The smaller ones, red dwarfs, can burn quietly for trillions of years, far longer than the universe has existed so far. When every other star has faded, the red dwarfs will still shine faintly, keeping the darkness company. You drift among a cluster of newborn stars, their light sharp and white. Around each one spin disks of dust, glowing faintly in infrared. The airless silence hides immense activity, winds, radiation, and gravity shaping everything at once. The light here feels young, eager, restless. These are the galaxy's children, and they will grow for eons before settling into calm adulthood. Scientists study the vibrations of stars, tiny changes in brightness or movement that reveal their structure. It's called astroseismology, the study of starquakes. Just as seismologists learn about Earth's interior from earthquakes, astronomers read the music of stellar oscillations to know what lies within. You imagine those waves rolling through plasma, rippling across the surface like tides of flame. The star hums to itself, and if you could translate it, it would be a note too deep for any instrument to play. Stars also have cycles, periods of calm and activity. The Sun, for example, follows an 11-year rhythm of sunspots and flares. During peak activity, its magnetic field twists violently, releasing energy that can travel all the way to Earth, painting auroras across polar skies. You remember those lights, the green and purple ribbons dancing above frozen landscapes. What you saw as beauty was, in truth, the breath of a star brushing against your atmosphere. You glide to the side of the star and see jets of plasma arcing outward, curving along magnetic lines. These loops can stretch hundreds of thousands of kilometers, large enough to engulf planets. They twist, break, and reform, releasing bursts of radiation known as solar flares. When these reach Earth, they can disrupt satellites, darken power grids, even make the upper atmosphere ring faintly with radio waves. The universe is vast, but it never loses contact with its smallest parts. As you move through this radiant landscape, you notice faint, flickering companions, binary stars. Many suns come in pairs or trios, orbiting one another in gravitational dance. Some are close enough that they share material, trading streams of plasma like partners exchanging breath. Others orbit far apart, their connections stretched thin across light years, but unbroken. You realize that even in the coldest regions of space, there are relationships that endure. Scientists still wonder how stars form in such variety. Why do some become giants, others dwarfs? Why do some explode while others fade quietly? The equations describe mass and temperature, but they don't explain personality, the subtle individuality that each star seems to carry. Some blaze bright and vanish quickly. Others glow softly, patiently, almost lovingly. The physics is precise, but the experience feels emotional. You drift onward, passing a star near the end of its life, a red supergiant, vast and swollen, its outer layers rippling like a slow heartbeat. Its light is warm, but unsteady. Inside, the fusion of heavier elements has begun, layer upon layer, like the rings of an onion. Each stage releases less energy than the last, until soon, gravity will win. You can sense its exhaustion, its dignity. Even in death, the star gives everything it has. You realize how fragile existence is, even for something so immense. Stars spend most of their lives in delicate balance, gravity pulling inward, pressure pushing outward. The moment that balance fails, the story changes forever. You think of the atoms within your own body, once forged in such a furnace. Perhaps they came from a supernova, long vanished, scattered across space before gathering into a new star, a new planet, a new being into you. You are, in a literal sense, the continuation of stars. Their light burns in your veins, as surely as it burns in the sky. You turn your gaze once more toward the wider galaxy, where millions of stars burn together, their light blending into a soft glow. Each is a story, a heartbeat, a moment in the long breath of the universe. You drift among them quietly, feeling not like a visitor, but like a participant, one more spark in the grand fusion of everything that ever was. And as you move deeper into that infinite ocean of suns, you feel something profoundly calm, the awareness that the same forces that sustain those distant lights are at work inside you right now. The same physics, the same chemistry, the same rhythm. You are not beneath the stars, you are among them. You drift onward, leaving the realm of youth and creation behind. Ahead, the stars grow older, dimmer, heavier. You sense something changing. In the tone of the light it feels slower, deeper, like a song reaching its final verse. The cosmos is patient, but nothing lasts forever. Here, among these elder suns, you begin to witness what happens when giants fall silent. A red supergiant looms before you, immense beyond comprehension. It's swollen to hundreds of times the size of the sun, glowing a soft, mournful crimson. Its surface ripples with slow, vast convulsions, each one a sigh from a dying heart. You watch it pulse gently, shedding layers of gas into space like the petals of a fading flower. Around it forms a halo of dust, shimmering faintly in the starlight. This star is nearing the end. Its fuel is nearly spent. Inside, fusion has reached its final stages, no longer turning hydrogen into helium, but forging heavier elements: carbon, oxygen, silicon, iron. But iron is different. It does not yield energy when fused. It resists, and with it comes collapse. Deep within, gravity begins to win. You can feel the tension, though there's no sound. In one single moment so brief it defies imagination, the core implodes. The outer layers crash inward, then rebound violently outward. A shockwave rips through the star's body. The light that bursts forth outshines entire galaxies. A supernova. It's hard to describe what you see. It's not an explosion in the ordinary sense, but an unmaking of identity. The star becomes a million suns worth of brilliance in an instant, then fades just as quickly into dust. The shockwave travels outward at thousands of kilometers per second, scattering elements into space. Iron, gold, uranium. All the heavy atoms that make up mountains, blood, and bone are created in this chaos. The death of one star becomes the foundation for worlds yet to be born. It is both beautiful and humbling. The end of a life that began millions of years ago has just made the possibility of countless others. You drift through the expanding cloud, glowing with residual heat. The atoms here are newborn, but already ancient. They will travel for billions of years before finding another home. Perhaps one day they will form oceans or forests, or the eyes of some future being who will also wonder what lies beyond the stars. You move away from the fading light and find something darker, smaller, and stranger. It is what remains when the explosion's fury cools a neutron star. It's only a few kilometers wide, yet heavier than the entire Sunday. You approach carefully, feeling the tug of its gravity even from far away. The space around it warps like glass under pressure. The surface gleams faintly, smooth and metallic. It spins rapidly, hundreds of times each second, sending beams of radiation sweeping through space. When those beams align with your view, the star seems to flash a cosmic lighthouse, marking its lonely existence. Astronomers call these pulsars. Each pulse is so precise that you could set your watch by it. If you could stand on its surface, which you can't, gravity would crush you instantly, thousands of billions of times stronger than Earth's. Even atoms struggle here. Electrons and protons are squeezed so tightly they merge into neutrons. The result is matter in its densest known form, a single teaspoon weighing as much as Mount Everest. A quirky fact: scientists have discovered pulsars that glitch, suddenly changing their spin rate as if hiccuping. They think it's caused by cracks forming in the star's crust, tiny shifts that release immense energy. It's a reminder that even in death, stars remain restless. You continue drifting through this graveyard of suns. In the far distance, you see something darker, still a black hole, the ultimate quiet. It's the remnant of a star, even larger than the one you saw die. When it collapsed, nothing could stop its gravity. Space folded inward until not even light could escape. You can't see the black hole directly. It hides behind its event horizon, the boundary where escape becomes impossible. But around it swirls an accretion disk, a whirlpool of gas and dust spiraling inward, glowing fiercely as it falls. The light flickers in strange rhythms, distorted by gravity. Time itself seems to bend here. If you could hover near the edge, a single minute for you might pass as centuries for someone watching from afar. The edge of the event horizon glows faintly with blue and gold arcs, where matter reaches unimaginable speeds. The photons that escape come from moments before oblivion. You realize you're seeing the very limit of observation, the point where the universe stops telling us what happens next. Scientists still wonder what truly lies beyond that threshold. Is it a singularity, a point of infinite density, or a bridge to somewhere else entirely? No one knows. You watch in awe as a stream of particles jets from the black hole's poles, moving at nearly the speed of light. They stretch for thousands of light years, thin and radiant. Paradoxically, even in consuming everything, the black hole creates beauty light born from darkness, energy from annihilation. You drift closer, and space begins to distort. Stars behind the black hole appear warped, as though reflected in rippling water. This is gravitational lensing, the bending of light around extreme gravity. The cosmos paints its own illusions, turning reality into art. You can't help but think how even destruction here follows its own kind of grace. There's a calm in it all, an inevitability. Every star will reach its end, but every ending gives something back. Supernovae seed galaxies. Neutron stars keep time. Black holes sculpt the very fabric of space. It's a cosmic recycling so complete that nothing is ever truly lost, just transformed. A faint memory returns to you. The atoms in your own body, born from long-dead stars. The calcium in your bones, the iron in your blood, all once part of some distant supernova's farewell. You realize that death in the universe isn't a tragedy. It's continuity. It's renewal. The light you see now was forged in endings, yet it burns with beginnings. You drift through the cooling remnants of the exploded star. Dust gathers again, drawn by gravity, preparing for the next cycle. Somewhere, perhaps in 1 billion years, this debris will form a new sun, a new system, new worlds. The nebula behind you, the dying stars before you, they are chapters of the same eternal story. And as you float onward, you feel it deep within, that even endings, when seen from far enough away, are just another kind of creation. The universe never stops breathing. It only changes rhythm. You drift closer to the deepest shadow you have ever seen. It isn't the absence of light, it's something more profound, a presence that devours brightness itself. Around you, stars curve, as though bowing toward a hidden power. The glow of distant galaxies bends into circles and arcs, their lights stretched and folded. You have arrived at the edge of a black hole. It feels impossible that something invisible could command such reverence from everything around it. The air, if there were air, would tremble. Space itself leans inward. This is the event horizon, the boundary where gravity grows so absolute that escape becomes a myth. Anything that crosses it, from dust to light, falls inward forever. You hover just outside that invisible surface. From here, you can see the accretion disk, a whirl of plasma spiraling toward oblivion. The material glows hotter than any star, spinning faster than thought. To your eyes, it looks alive, flowing like molten gold. Sparks of X-rays flash outward, proof of atoms being torn apart by speed alone. It's beautiful in the strangest way, terrifying, yet tranquil. You feel like you are witnessing the purest form of stillness disguised as motion. Every flicker of light you see comes from particles screaming their final song before disappearing beyond reach. You notice the way time behaves differently here. For you, the moments pass normally, but if someone far away were watching, they'd see you slow down, almost freeze, your descent stretched to eternity. The closer you approach the event horizon, the slower time flows. At the boundary itself, it stops entirely. That's the paradox of black holes. They trap not just matter, but time itself. You wonder what happens to the information everything that falls in. Physicists argue over it still. Some say it's destroyed, others that it's preserved on the surface of the event horizon, encoded in quantum ripples like cosmic braille. The information paradox. They call it a riddle that has kept scientists awake for decades. You let the thought drift through you, too large to solve, yet soothing in its mystery. Then you notice something extraordinary. Light bending around the black hole, completing a full orbit before continuing on its way. This is the photon sphere, a perfect circle where gravity bends light into loops. You realize that even here, where nothing can escape, light finds ways to linger. You drift a little closer. Around you, the stars behind the black hole smear into rings of fire. This isn't illusion, it's lensing gravity sculpting light itself. Einstein predicted this long before anyone had seen it. And now, as you float here, you see the equations turned into reality. The cosmos is doing mathematics with color. A curious fact: in 2019, scientists captured the first image of a black hole using a planet-sized telescope network called the Event Horizon Telescope. What they saw matched Einstein's prediction almost perfectly. A dark circle surrounded by a bright, uneven ring of light. It was the silhouette of the unseeable, a photograph of pure gravity. Humanity had looked into the abyss and, for the first time, seen a reflection. You drift along the accretion disk, where temperatures soar to millions of degrees. If you could hear it, which you can't, the sound would be a low, continuous roar, like the universe exhaling. Yet, it's silent, eerily so. You're moving through radiation that could strip atoms bare, yet here, in the hush of your mind, it feels peaceful. You think about what lies inside, beyond the horizon. The equations say there's a singularity, a point of infinite density, where all known physics breaks down. Space curves inward so sharply that direction loses meaning. Time itself collapses, but perhaps it isn't truly a point. Some theories suggest it's a doorway, a tunnel, a wormhole, to another region of spacetime. Others think black holes could birth new universes, each sealed away from ours, expanding unseen. Scientists still wonder which vision is true. No one can test it. Once something crosses the horizon, it can never return to tell the tale. The mystery remains perfect because it's eternal. You feel a strange pull, not of gravity, but of curiosity. You imagine falling in, not as destruction, but as transformation. To fall into a black hole is to trade space for time, to move forward not through distance, but through inevitability. Every atom would stretch into a line of pure energy, an echo fading into infinity. And yet, to an outside observer, you would never truly vanish. You'd remain frozen on the edge, eternally visible, eternally unreachable. You notice faint arcs of matter being flung away from the poles, jets of plasma, traveling near the speed of light. They shoot outward for thousands of light years, straight as arrows, visible in radio waves. These jets, born from devouring gravity, light entire galaxies. Even as the black hole consumes, it creates radiance. You realize that the universe has no clean separations between death and birth, only cycles of exchange. You drift above the jet, feeling its invisible vibration. If you could see in radio frequencies, it would blaze brighter than the Sunday. You trace its path outward until it dissolves into interstellar space, feeding the clouds that may one day become stars. Even here, at the heart of darkness, the seeds of creation are scattered. You think about how black holes anchor galaxies. At the center of nearly every one lies a supermassive black hole, millions or even billions of times heavier than the Sunday. The Milky Way's own core harbors one called Sagittarius A*, quietly shaping the orbits of hundreds of billions of stars. Without that hidden heart, your galaxy would not hold together. What feels like destruction is actually structure, the dark spine of existence. A gentle thought arises. Maybe darkness is not the opposite of light, but its partner. The two define each other. The black hole consumes, the stars shine, and between them, the universe breathes. You can't have one without the other. You let yourself drift a little farther from the edge. The light grows steadier again, less distorted, less urgent. Behind you, the black hole remains still, serene, unknowable. It's easy to fear it when you're far away, but up close, it feels strangely honest. It doesn't pretend to be more than it is. The pure expression of gravity, the place where time and matter surrender. You look once more toward the distant stars and realize something profound. Every photon that escapes their surfaces does so because of gravity's restraint, and every photon lost to a black hole reminds you that even freedom has its limits. Yet in that balance between light and dark, between motion and stillness, you find peace. You turn slowly away, carrying the image of the dark sphere with you. It's not menace you leave behind, but mystery, a silence so deep that it becomes its own kind of beauty. And as you glide onward, through the slow shimmer of distant galaxies, you can still feel the echo of that gravity, tugging softly at your thoughts, reminding you that even the darkest places in the universe are part of the same luminous whole. You drift on, carried by the invisible momentum of curiosity, until the black hole's shadow dissolves behind you. The stars reappear familiar, delicate, scattered across the darkness like diamonds resting on deep water. The airless silence feels lighter now, full of potential again. Yet a question remains in the quiet corners of your mind. What if there are shortcuts hidden within this cosmic sea? The thought feels almost like a dream, a passage through space-time tunnels connecting distant points in the universe. The idea has a name whispered with equal parts, wonder and doubt: wormholes. You turn toward that possibility, and the space around you seems to ripple slightly, as though responding to the thought itself. Einstein's equations allow such structures bridges through space-time, called Einstein-Rosen bridges. Mathematically, they could exist, curved geometries that link two distant regions of the cosmos, like tunnels beneath an ocean. You picture it now, a shimmering mouth of light and distortion, like a whirlpool in the fabric of reality. If you could enter, you might emerge light years away in an instant, skipping the vast gulfs between stars. To an observer, it would look like folding the universe, bringing two faraway points together until they touch. But the equations also whisper warnings. Such tunnels, if they exist, would be unstable. Gravity itself would try to crush them shut faster than anything could pass through. They might flicker into existence and collapse again before even a single photon could cross. Some physicists have suggested that a kind of exotic matter with negative energy could hold them open, but no one has ever found such a substance. Scientists still wonder whether wormholes are genuine possibilities or merely beautiful illusions of mathematics. You drift through this thought, feeling the tension between imagination and reality. The universe is full of geometry we can't yet touch. Perhaps wormholes are like dreams the cosmos has not yet learned to build. Still, you wonder, if they could exist, where would they lead? To another corner of the same universe? Or perhaps to an entirely different one? Some theories say wormholes might connect not just points in space, but moments in time. You could, in principle, leave one mouth and emerge not only far away, but also in another era. Time travel, then, might not require machinery, just geometry. The idea fills you with a strange calm. Maybe the future is not unreachable. Maybe the past isn't truly gone. Perhaps both are folded neatly within the same grand tapestry, waiting for a curious traveler to trace their threads. You pass through a region where gravity feels uneven, as though invisible currents tug and twist. The stars seem to shift position subtly, bending inward toward a faint shimmer ahead. You realize you're approaching what could be a hypothetical wormhole throat, if only such things were real. You let yourself imagine it anyway. The space before you folds softly. It doesn't explode with light or swallow you whole, it just changes. The stars warp into rings, then spiral into a tunnel of color. It feels like slipping beneath the surface of a still pond, gentle and soundless. You are neither moving nor standing still. Everything around you becomes a slow swirl of time and light. The walls of the tunnel shimmer, rippling like silk. You see hints of distant galaxies imprinted faintly upon them, as though light from other corners of the universe is glancing off the inside of this impossible bridge. You can almost feel space-time flexing, smooth, elastic, alive. Physicists call this geometry non-trivial topology, which sounds cold, but in truth, it means something simple. The universe might be connected in ways we can't easily imagine. Space might loop, fold, or intertwine, allowing paths between places that appear separated. You think of it like tunnels through a mountain range. The mountain looks solid from afar, but inside, passageways wait. A quirky detail: if wormholes exist, they might allow mirror travel. Objects entering one mouth might emerge. Inverted left becomes right, forward becomes backward. It's pure speculation, but you smile at the thought of the universe playing tricks with symmetry, as if every shortcut came with a reminder that balance must be kept. You notice how calm it feels inside this imagined passage. There's no sense of speed. The motion you experience is purely visual, a drifting of patterns and colors, slow enough to soothe. It feels as though time itself is cushioning you, stretching gently to prevent any rush. You think of the human need to explore, to find ways past every limit. Wormholes, whether real or not, embody that instinct perfectly. They are the universe's whisper, that distance might not be the final boundary. Perhaps curiosity itself is the force that keeps such ideas alive, just as gravity holds stars together. The tunnel begins to open again. The stars ahead grow distinct, sharpening from mist into points of light. You emerge softly, not into chaos, but into calm, a new stretch of space where the galaxies seem subtly rearranged. You can't tell if you've traveled across unimaginable distance or merely blinked. But it doesn't matter. The act of imagining it was enough. Scientists are cautious about wormholes. The mathematics fits, but the evidence doesn't. The energies required would dwarf anything our civilization could create. Even if they exist naturally, they may hide behind horizons, or deep within quantum foam, those tiny fluctuations where space-time itself writhes at the smallest scales. Some physicists think microscopic wormholes might constantly appear and vanish within that foam, connecting regions smaller than atoms. You might be surrounded by them right now, billions forming and collapsing every second, invisible bridges flickering like sparks inside reality. It's comforting in a way to think that connection exists everywhere, even where we cannot see it. Space may look empty, but it could be threaded with unseen doorways. Perhaps everything, from galaxies to thoughts, is linked by paths we'll one day learn to trace. You look around, and the stars seem somehow closer now, not physically, but emotionally. The idea of shortcuts makes the universe feel intimate, not infinite. It reminds you that distance is often a matter of perception. Even across light years, connection is possible through imagination, through gravity, through light itself. You drift gently, letting the fantasy settle into calm acceptance. Whether wormholes are real or not doesn't change their beauty. They remind you of a truth older than science, that wonder itself is a bridge, a way of traveling between what you know and what you dream. The cosmos stretches endlessly around you, full of paths both known and unknown. You breathe softly, your thoughts as weightless as starlight. In the quiet between moments, you sense that maybe every question you ask is its own kind of journey, each one bending space just a little, opening new ways to see. And as you drift onward, the imagined tunnel fades behind you, leaving only the steady glow of distant galaxies ahead. The stars feel close again, as though the universe, in its own quiet generosity, has already folded itself to meet you halfway. You emerge into a wide, open expanse where stars no longer stand alone. They gather, clustering in vast cities of light spiral arms, elliptical bulges, arcs of gold and sapphire. You are drifting through galaxies now, each one a masterpiece, each one turning slowly in a cosmic waltz that has lasted billions of years. From here, the universe feels alive with motion. You can almost sense the rhythm of it, the slow spin of spiral galaxies, the collisions of clusters, the endless ebb and flow of gravity drawing matter into graceful patterns. You drift nearer to one of them, the familiar shape of a spiral unfurling before you like a giant seashell. The Milky Way looks serene from a distance. Its arms curve in luminous ribbons, each packed with hundreds of billions of stars. Dark lanes of dust twist between them, hiding newborn suns and glowing clouds. You glide above the plane, watching how it all rotates in quiet harmony. At its center lies the galactic bulge, dense and golden, where stars crowd so closely that their light merges into a soft radiance. And hidden at the heart of it all, you know, is a supermassive black hole, an anchor of invisible gravity keeping everything bound together. Every galaxy you see shares this secret. They are not static, they are dancers, each moving according to gravity's music. The Milky Way itself is gliding through space at more than 2 million kilometers per hour on a slow collision course with its nearest large neighbor, the Andromeda Galaxy. In about 4 billion years, the two will meet, their spiral arms intertwining like ribbons in slow motion. To human eyes, it will look like chaos. To the cosmos, it will look like embrace. You imagine that moment, two galaxies colliding, not with sound or flame, but with silence. Their stars will mostly pass by one another, untouched. So vast is the space between them that true collisions are rare. Instead, gravity will twist their shapes, sending tidal tails of light sweeping outward. Gas clouds will compress, igniting bursts of star formation. Whole new generations of suns will be born from the meeting of ancient ones. In that slow cosmic dance, destruction and creation will once again blur into one. You turn your gaze farther outward and see other galaxies scattered like islands across a black ocean. Some are small and irregular, others immense and symmetrical. A few glow red, weary with age. Others blaze blue with young, hot stars. The light from the farthest ones has been traveling for billions of years, showing you not what they are, but what they were. You are looking back through time itself, watching galaxies as they were when the universe was still new. A curious fact, galaxies are not evenly spread across space. They form clusters and filaments, connected by invisible threads of gravity and dark matter. Between these filaments lie vast voids, regions nearly empty of galaxies, hundreds of millions of light years wide. You float now near the edge of one such filament, where galaxies stretch like pearls along an unseen string. Their motion is slow, yet purposeful. It feels like watching the universe weave itself. You notice pairs of galaxies swirling together, locked in gravitational embrace. These are interacting systems, merging in elegant chaos. When they collide, their stars rarely touch, but their gas and dust crash and compress, igniting new light. The result is spectacular. Luminous bridges, arcs, and tails that span hundreds of thousands of light years. From your vantage point, they look like brushstrokes of light across the black canvas of space. Some galaxies are even stranger. You spot one shaped like a perfect ring, another twisted into a bar. Others appear like scattered smudges, dwarfs containing just a few million stars. Each one, no matter how humble, carries its own history of formation, collision, and change. The diversity is staggering, yet the laws guiding them are the same everywhere. Gravity never improvises. It only varies its tempo. You drift through a galaxy cluster now, a massive gathering of thousands of galaxies, bound together by mutual attraction. Their combined gravity is so strong that it bends light from even more distant objects behind them, distorting them into stretched arcs. This phenomenon, gravitational lensing, turns the cluster into a natural telescope, magnifying the background universe. You realize that galaxies themselves are instruments, allowing us to see farther than our own technology ever could. A faint glow fills the space between galaxies here, the intra-cluster medium, made of hot, thin gas, left behind by supernovae and stripped from wandering galaxies. It's invisible to your eyes but radiant in X-rays, filling the gaps with quiet fire. Even the void between worlds, it seems, is alive. You pass a small elliptical galaxy, its stars older, redder, dimmer. It feels like a retirement home for suns, no new stars forming, only the gentle fading of those that remain. Yet there's a kind of peace in it, a serenity that only age can bring. These galaxies are the slow heartbeats of the universe, reminders that even in stillness there is purpose. Scientists still wonder how galaxies first formed. Did they begin as small clumps of matter merging over time, or as immense structures collapsing under their own weight? The answers lie hidden in the oldest light, faint and distant, reaching us as whispers from billions of years ago. The James Webb Space Telescope has begun to reveal some of these secrets, capturing galaxies so young that their stars are only just beginning to ignite. Each new discovery adds another verse to the cosmic story, a story still being written. A quirky detail. If you could step back far enough, beyond all clusters and filaments, the pattern of galaxies would resemble something familiar, a web. Not random, but connected, as though the universe were shaped by a hidden hand weaving order through chaos. This pattern repeats at every scale, from small groups of galaxies to the largest cosmic structures ever mapped. It's as if the universe prefers symmetry, a gentle aesthetic, even in vastness. You drift among these swirling cities of light, feeling their gravity tug faintly at your path. The galaxies move so slowly that to your eyes, they seem still. Yet you know that each one is racing through space, shaped by the pull of its neighbors, by dark matter, by the whispering expansion of the cosmos itself. Nothing truly rests. Everything participates in this slow, grand choreography. You think of your own galaxy again, the Milky Way, your home adrift among billions. It, too, is part of this dance, circling unseen centers, merging and transforming, giving birth to new stars even as old ones fade. You are not separate from this motion. Every atom in you participates. You are orbiting with the Earth, spinning with the Sun, flowing with the Milky Way through the local group and beyond. As you watch, two distant galaxies cross paths. Their spiral arms blend in a luminous embrace, forming a single new shape, a bridge of stars, glowing softly in the dark. You realize you are witnessing love on a cosmic scale, the quiet union of light and gravity, destined to merge over billions of years. And as you drift through this cosmic dance hall, surrounded by silent music, you understand something simple, yet profound. The universe is not expanding into emptiness. It is expanding into itself, each motion, a note, in an endless, beautiful composition of change. You exhale, though there's no air, and the stars seem to pulse in rhythm with you. You drift forward, feeling as though you're gliding not just through galaxies, but through the quiet truth that everything, every life, every light is part of a single, graceful motion that never truly ends. You drift along the outer edges of the galactic cluster, where the stars grow sparser and the spaces between them begin to widen again. The light thins, and the darkness deepens into something richer, textured like velvet. You begin to notice the unseen architecture of everything, the faint gravitational web that holds galaxies together. It's invisible to your eyes, but you can feel it tugging softly at your path, like an unseen current beneath a calm sea. This is the domain of dark matter, the silent framework of the cosmos. It neither glows nor absorbs light, yet it makes up most of the universe's mass. Everything you can see, the stars, planets, gas clouds, even the light itself, accounts for less than 5% of what truly exists. The rest lies hidden in shadow, unobservable but undeniable. You float quietly, and for a moment you try to imagine it. A vast, invisible lattice stretching across the universe, connecting galaxies like beads on invisible threads. The galaxies are merely ornaments, glimmering upon the unseen skeleton that dark matter forms. Without it, the cosmos would fall apart. Scientists first suspected dark matter when galaxies began to misbehave. Astronomers expected that the outer stars of a galaxy would move more slowly than those near the center, just as planets in our solar system orbit the sun at varying speeds. But when they measured the rotation curves, they discovered something odd. The outer stars moved just as fast as the inner ones. Something massive, unseen, was keeping them bound. You look out across the cluster and imagine those invisible halos surrounding every galaxy. They extend far beyond the visible stars, hundreds of thousands of light years into space. If you could see them, the galaxies would look like glowing seeds, encased in enormous translucent spheres. Dark matter doesn't emit light, but its gravity sculpts the cosmos, gathering matter into filaments, forming the scaffolding upon which galaxies grow. A curious fact: no one knows what dark matter is made of. It doesn't behave like ordinary atoms. It doesn't collide or radiate. Some think it consists of exotic particles, weakly interacting massive particles, or WIMPs. Others imagine axions, ghostly quanta that slip through matter unnoticed. Some even suggest dark matter might be made of countless tiny black holes, relics of the early universe. Despite decades of searching, no one has caught it, not in a detector deep underground, not in the vacuum of space. And yet, you can feel its presence everywhere. It's in the quiet pull between galaxies, in the way clusters form, in the bending of light across immense distances. When light from a distant quasar passes through a dark matter halo, it distorts and multiplies, revealing the shape of the invisible. The universe, you realize, leaves fingerprints even for what it hides. You drift through one of these invisible halos now. There's no color, no light, no warmth, just an eerie serenity. You imagine the dark matter particles passing through you, countless and silent. They don't touch you, don't react, but their collective presence guides everything you see. It's as if the universe has chosen to build its masterpiece on an invisible canvas. You remember that without dark matter, galaxies could never have formed. In the early universe, normal matter, hydrogen and helium, was too diffuse to clump together on its own. Dark matter provided the gravitational wells that gathered gas, allowing stars to ignite. Every sunrise, every spark of life, owes its existence to something unseen. Scientists still wonder what dark matter might reveal about the deeper structure of reality. Could it be evidence of hidden dimensions, curled up in space smaller than atoms? Or perhaps it's the shadow of a parallel universe, leaking gravity across the boundary between worlds. Theories multiply like stars, each beautiful in its own way, each incomplete. You drift closer to a cluster's center, where dark matter density peaks. Here, gravity bends light so strongly that you can see galaxies duplicated and stretched around invisible arcs, lensing effects from an unseen mass. It's like the universe's handwriting, scrawled in curves of light. You can trace those arcs and know the weight of what cannot be seen. It occurs to you that the universe hides most of itself, not out of malice, but necessity. Mystery, perhaps, is its natural state. The unseen gives meaning to the seen. Just as silence shapes music and shadows shape light, the invisible gives form to existence. You begin to feel that darkness is not emptiness. It is the deep structure of being. You imagine reaching out and touching it. It doesn't resist or yield. It simply is. It has no temperature, no texture, and yet it holds galaxies in its embrace. If the universe were a body, dark matter would be its bones strong, unseen, supporting every luminous movement. A quirky detail: the name dark matter might be misleading. It isn't necessarily dark. It's simply transparent, invisible to light. It neither glows nor blocks, neither shines nor shadows. It's everywhere and nowhere, a paradox that quietly underlies all creation. You glance across the sky again. Everywhere you look, galaxies float within invisible cocoons, their rotations steady, their orbits balanced. You realize that you, too, are part of this hidden architecture. The Earth moves through a river of dark matter constantly, billions of particles passing through your body every second, unnoticed. Even now, as you drift here in imagination, you are immersed in it. You let that awareness settle into calm acceptance. Not everything that matters must be visible. The universe's deepest truths often lie beneath perception, waiting to be felt rather than seen. You begin to understand why astronomers study darkness with such devotion. It isn't emptiness they seek, but connection. You turn slowly, looking back toward the galaxies behind you, glowing gently against the unseen web that binds them. It strikes you how balanced it all is: light and shadow, known and unknown. The visible world is just the surface of something vast and intricate. The stars seem to pulse faintly, as if nodding in agreement. You think of the dark matter holding them, patient and steady, the quiet guardian of structure. Without it, nothing would endure long enough to shine. And as you drift onward through that invisible sea, you feel no fear, only wonder. The unseen world is not separate from you. It's the space between every heartbeat, the gravity in every glance, the hidden foundation of everything you love. The cosmos holds you too, within its invisible arms. You continue your silent journey through the endless dark, where galaxies drift like lanterns carried by unseen hands. Between them, the darkness deepens into something stranger. Still, a force not just hidden, but active. You begin to sense it now, faint but steady, like a low tide slowly pulling everything outward. This is the quiet hand of dark energy, the mysterious pressure that makes the universe expand faster with every passing moment. It's subtle, almost imperceptible, yet everywhere. You feel it in the slow stretching of the stars, in the way galaxies recede like ripples spreading across a cosmic pond. For most of history, the universe expanded, but slowed down under its own gravity. Then, about 5 billion years ago, something changed. Instead of slowing, the expansion began to speed up. The galaxies started to drift apart faster and faster, as though the very fabric of space had learned to breathe outward. No one knows exactly why. Scientists call the cause dark energy, not because it's truly dark, but because it hides behind every explanation we've tried to give it. It fills all of space evenly, silent and persistent, pushing galaxies apart with gentle insistence. You imagine it as a kind of cosmic wind, invisible yet constant, flowing through everything. If you could see the expansion, you'd notice galaxies receding faster the farther away they are. The universe isn't growing into something, it's stretching itself. Space isn't a stage where matter moves. It's an actor, expanding between every star, every atom. You feel it now, the slow, serene widening of everything that exists. A curious fact: astronomers discovered dark energy almost by accident. In the 1,990 seconds, they studied distant supernovae, exploding stars so bright they serve as cosmic mile markers. By measuring their light, scientists could determine how fast the universe was expanding billions of years ago. To their surprise, the expansion wasn't slowing down. As expected, it was accelerating. The discovery earned them the Nobel Prize, and it changed our understanding of everything. You gaze into the distance, and you can almost sense that acceleration, the galaxies sliding away like gentle raindrops on a window pane. Over billions of years, this expansion will continue, stretching the distances between every cluster until the universe becomes quieter, emptier, more diffuse. The stars will seem to stand still to any observer, but they're drifting, carried outward on the current of dark energy. Some physicists believe dark energy is a property of space itself, a cosmological constant that Einstein once introduced, then abandoned, then was proven right about after all. Space, it seems, is not nothing. Even empty space holds energy, like a quiet hum beneath silence. This vacuum energy might be the source of the acceleration, the reason the cosmos can't stop expanding. But there are other theories too. Some imagine a new kind of field pervading the universe, a dynamic energy that changes over time. Others suggest we're seeing the effects of hidden dimensions, where gravity leaks differently across scales. Scientists still wonder whether dark energy is a force at all, or merely the reflection of a deeper geometry we've yet to understand. You drift through the expanding void, and the galaxies ahead seem to recede a little faster. You realize that this expansion doesn't happen in time, it happens to time. Space and time stretch together, the rhythm of existence itself slowing and lengthening, like the fading echo of a song. If you could watch long enough, you'd see galaxies slip beyond visibility. Their light, stretched by expansion, would fade into infrared, then microwave, then nothing. The night sky would grow emptier, the stars thinning until only your local cluster remained, and even that would eventually drift apart, carried by a force that never tires. A quirky fact: the expansion doesn't affect everything equally. Gravity holds local systems together. The Earth will not drift from the Sun, nor the Sun from the Milky Way. Expansion happens on scales where space itself dominates between galaxies, across vast cosmic distances. It's as though the universe knows where to stretch and where to stay still. You think of how delicate that balance must be. Too much dark energy, and galaxies would never have formed. Too little, and the universe might have collapsed back in on itself. Somehow, the amount that exists seems tuned for life, for stars to shine, for planets to form, for minds to wonder. Whether that balance is coincidence or design, no one knows. But it feels deliberate, as though the cosmos has chosen to give itself time to think. You pass a faint glow ahead, a relic of early light, stretched thin by eons of expansion. It's the cosmic microwave background, the afterglow of the Big Bang, now chilled to just a few degrees above absolute zero. It fills all of space, faint but perfect, a reminder that even as the universe expands, it never forgets where it began. You imagine dark energy at work then, in the background of creation, patient and quiet. It doesn't fight gravity. It simply waits until gravity grows weary. Then, it takes over, not violently, but gently, pushing galaxies apart like leaves on a widening pond. It's not destruction, it's the universe breathing out after a long inhale. Scientists debate what this means for the future. Some predict a big freeze, where expansion continues until stars exhaust their fuel and galaxies drift into eternal darkness. Others envision a big rip, where dark energy grows so strong that it eventually tears galaxies, stars, planets, even atoms apart. And some suggest it will slow again, perhaps reversing one day into a new collapse, a cyclical heartbeat of creation and return. You think of all those possibilities and feel no fear. They are not endings, just variations in tempo. The universe has always changed, always expanded, always transformed. Whether it continues forever or folds back into itself, the beauty remains. You imagine yourself as part of that expansion, your atoms stretching imperceptibly with space, your thoughts widening with understanding. You are not separate from this process. The same energy that pushes galaxies apart flows through you too, in the spaces between your molecules, in the pauses between your breaths. A soft calm settles over you. You realize that dark energy, mysterious as it is, represents not emptiness, but freedom. It's the reason there is always room for more stars, more time, more thought. The universe is not confined. It grows, it reaches, it explores. You look once more toward the horizon of stars. They shimmer faintly, their light softened by distance, and you can almost feel the expansion slow, steady, eternal. The galaxies drift apart, but their light still meets in your eyes, proof that connection defies even the forces that try to separate it. You exhale into the silence. The stars feel both near and impossibly far, and you understand. Dark energy isn't just pushing space apart, it's reminding the universe to keep moving, to never stop creating new room for possibility. You continue gliding through the vast dark, where galaxies recede quietly into the infinite. The silence becomes deeper, almost holy, and through that stillness you begin to hear something subtle, a background whisper, like the softest static, stretching from every direction. It isn't the sound of space, it's the echo of time itself. You have arrived at the faint, ancient memory of the universe's birth, the cosmic microwave background. It's everywhere, woven into the very fabric of existence. No matter where you go, no matter which direction you turn, it surrounds you equally steady, calm, ancient. It is the afterglow of the Big Bang, the faint radiation left from when the universe was less than 400,000 years old. In that era, everything was so hot and dense that light couldn't travel freely. The cosmos was filled with an opaque fog of plasma particles of matter and light entangled in a blinding storm. Then, one quiet moment changed everything. As the universe expanded and cooled, atoms began to form. Light was freed, no longer trapped, but able to move through space, unimpeded. That light still travels today, stretched over billions of years into microwaves, cooled to just 2.7 degrees above absolute zero. It fills all of creation, a soft, unending whisper. You close your eyes and try to imagine it as it was then, a universe not yet filled with stars, but with possibility. The first light moved freely at last, painting everything with a glow that would one day become the foundation for all structure. What you feel now, in the faint radiation bathing you, is the first true dawn. A curious fact, the cosmic microwave background, or CMB, was discovered by accident in 1965 by two radio engineers, Arno Penzias and Robert Wilson. They were trying to eliminate noise from a radio antenna, but no matter what they did, cleaning, recalibrating, adjusting, they couldn't remove the faint hiss. It was everywhere, constant and unyielding. They had stumbled upon the oldest light in existence, the residue of creation itself. You think about that, a soundless whisper that had been speaking since the beginning, finally heard by two people adjusting a telescope. It's humbling to know that the universe's first words weren't found in grand gestures, but in quiet persistence. You drift through that radiation now, and though your senses cannot perceive it directly, your imagination does. It feels like warmth that isn't warmth, like memory made tangible. Every direction you look glows faintly with the same light, perfectly, even, but not completely. Tiny fluctuations ripple through it, temperature differences so slight they are measured in millionths of a degree. Those minuscule variations became everything: galaxies, stars, planets, and eventually, you. You imagine looking at a map of the CMB, the mottled blue and gold image captured by satellites like COBE, WMAP, and Planck. Each spot, each fluctuation, is a seed of structure, a place where gravity began to gather matter. The universe's current form, the web of galaxies, the stars in the night sky, even your existence traces back to those tiny ripples in the afterglow. Scientists still wonder why the universe's early light is so smooth. Why was it so uniform, so balanced, with just enough variation to create everything we see now? Inflation theory offers one answer. It suggests that in the first instant after the Big Bang, the universe expanded faster than light itself, stretching microscopic fluctuations into cosmic scales. This inflation smoothed everything, but left behind those faint ripples, quantum whispers magnified into galaxies. You let the idea settle, like dust on water. The vastness of it feels gentle rather than overwhelming. You realize that the CMB isn't just a remnant of something long gone, it's a constant presence. It passes through you every second, through the Earth, through every star and planet. The universe has never stopped glowing, it has only dimmed into calmness. You imagine tracing that light backward in time, following the microwaves to their source. The farther back you go, the hotter the universe becomes. A few 100 million years after that first glow, the first stars ignite, flooding space with ultraviolet light that reionizes the cosmos. Before that, there is only the afterglow, soft and steady, like an eternal lullaby. A quirky fact: if your television set were tuned to static between channels, about 1% of that hiss would come from the cosmic microwave background. Even the noise of human technology still carries a faint echo of the universe's birth. You've been listening to it all along, without knowing it. The radiation feels almost affectionate, wrapping you in an invisible warmth. It's not enough to burn or freeze, just enough to remind you that everything began in light. That first illumination, traveling endlessly, has never stopped. It's just grown quieter, like a once loud symphony, playing its final, tender notes. You can sense how time has stretched it. What began as blinding light, hot and fierce, is now a cool, gentle glow that hums softly across the universe. Every photon has been traveling for 13.8 billion years, and yet it has never slowed. That means the light touching you now began its journey when the universe was still an infant, before galaxies or elements or atoms of your body even existed. Scientists call it relic radiation, but the word relic doesn't quite fit. A relic is something left behind. This is something ongoing. It is the pulse of the cosmos still echoing. The past isn't gone, it's still here, bathing every corner of existence in the memory of its first heartbeat. You think about how strange it is that such ancient light can coexist with the present. Somewhere, In its long journey, it passed through clouds that became stars, brushed by forming galaxies, grazed the edges of black holes, and still, it continues. Time means little to light. It simply travels. You realize that you, too, are made of this same continuity. The photons warming your skin on Earth come from the Sun, which was born from gas, enriched by older stars, which themselves condensed from the same primordial plasma that once glowed in the CMB. You're part of the same story, a ripple that began billions of years ago, now whispering itself through your existence. You look around again, and the background feels softer now, like a lull in a song. The galaxies ahead shimmer faintly against that ever-present hum. You understand that no matter how far you travel, the CMB will follow you. It fills everything, an eternal companion to space and time. It's comforting to know that the universe began not in silence, but in light, and that light still lingers, refusing to fade completely. The cosmos remembers itself through radiance, even as it drifts toward calm. You breathe in the quiet glow, feeling it wrap around you, gentle as sleep. The light from the beginning continues its endless journey, and in that persistence, you hear a truth older than language. Nothing truly vanishes, it only changes form, softens, cools, and carries on. The background glow fades into a softer haze as you continue drifting outward. The faint whisper of ancient light gives way to a deeper, more curious silence, one that feels full of anticipation, like the moment before dawn. Ahead of you glimmer countless suns, each one a promise, each orbited by worlds unseen. You are entering the realm of alien suns and distant worlds, the endless variety of planets that circle stars across the cosmos. They are everywhere. For most of human history, people looked up and wondered if other worlds existed. Now, science answers quietly. Yes, billions upon billions. Almost every star you see likely hosts planets, some as strange as dreams, some perhaps as familiar as home. You drift among them, letting curiosity be your compass. You pass a yellow-white star much like your sun, though its light feels slightly sharper, its warmth unfamiliar. Around it orbits a planet of brilliant sapphire, its atmosphere thick with methane. Its clouds swirl lazily, glinting with reflected starlight. From here, it looks peaceful, but below those clouds, the winds rage at hundreds of kilometers per hour. Lightning flashes faintly, coloring the darkness in soft violet bursts. You imagine standing on its surface, if you could, seeing a sky darker than ink, with a sun that never quite sets, only changes hue from gold to green as it sinks. Nearby, a smaller star glows orange and steady. Its planet lies close, so close that one side always faces the light while the other remains forever dark. The twilight zone between them is narrow and strange, a ring of eternal sunset where ice meets fire. On one horizon, the sky blazes orange. On the other, stars shimmer endlessly. You hover over the faint dividing line and feel a sense of balance so precise it seems sacred. A curious fact: astronomers have already found such worlds. They call them tidally locked planets, where one hemisphere basks in perpetual day and the other freezes in endless night. Yet even there, in that thin twilight band, life might endure beneath oceans, within clouds, or hidden under alien soil. Life, it seems, is stubbornly creative. You glide onward, and the light changes again. Ahead lies a red dwarf star, smaller and cooler, yet pulsing faintly like a heartbeat. Around it orbit several rocky planets. The innermost one scorches at thousands of degrees, its surface molten. The outer ones are colder, shadowed, but one in between glows, a dusky blue-green, the right distance for water to remain liquid. It might be a world like Earth, though its light is redder, its days longer, its oceans darker. You imagine looking up from its surface. The star would fill the sky, huge and crimson, rising slowly over alien seas. Scientists call this region the habitable zone, the band around each star where conditions might allow water, and thus life, to exist. But habitability isn't a single recipe. Some worlds may thrive under methane skies, others may shimmer with ammonia, oceans, or silica rain. Each variation, a verse in the same universal poem. You pass a planet twice the size of Earth, wrapped in thick silver clouds. It reflects so much light that it gleams brighter than its sunday. Beneath those clouds might be mountains of glass, or rain that falls not as water but as molten metal. On another world, the rain might be diamonds, forming deep within its atmosphere and falling in glittering storms. A reminder that beauty and strangeness often share the same sky. A quirky detail: astronomers have found a planet so close to its star that its atmosphere streams away like a comet's tail. Others orbit two suns, their skies painted with twin dawns and double sunsets. Some float freely between stars, cast off from their system's rogue planets, wandering through the dark, carrying their frozen landscapes like secrets. You drift past one of these lonely travelers. It glows faintly with residual heat, its surface cracked and silent. Beneath its icy crust, geothermal warmth might sustain oceans untouched by sunlight. You think of how life on Earth thrives in deep ocean vents, feeding not on light, but on chemical fire. Perhaps, somewhere on this wandering world, something similar stirs a reminder that even in solitude, life can find a way. Scientists still wonder how many worlds like this exist. Current estimates suggest there are more planets than stars, trillions in our galaxy alone. Some are gas giants, some rocky, some entirely unknown. Many orbit stars too faint to see without instruments, yet their presence is betrayed by small wobbles or fleeting shadows. We detect them not by sight, but by rhythm, the way a star's light dims slightly as a planet crosses before it. Each flicker, each subtle dip is a whisper, another world. You realize that the sky you once thought of as static is in fact a gallery of motion, filled with unseen travelers. Each star is not a single point but a system, a family. And in each family, there might be a world with rain, wind, oceans, clouds, even thoughts. You glide toward a planet with shimmering rings like Saturn's, but much brighter. They stretch across its horizon like a frozen halo, casting shadows across its moons. On one of those moons, faint auroras ripple across the sky, shimmering green and blue. The light pulses to a rhythm you can almost feel, like a gentle heartbeat echoing through the void. The sheer variety of these worlds feels endless. Some planets are covered in ice, so reflective they gleam like mirrors. Others are ocean worlds, with no land at all, just endless, rolling water under skies of ammonia and haze. Some are scorched to cinders, others never see daylight. Yet each one, in its way, holds a kind of beauty, an order, a balance. You pause in your drifting and let the view settle. The stars around you no longer look distant, they look alive, each one a home to its own story. You think about how small Earth is compared to all this, how rare it is that you can look up and know your planet harbors life. And yet, maybe it isn't rare at all. Maybe the universe is generous, scattering the ingredients of awareness like seeds in a vast garden. Scientists still debate what defines life. Must it breathe, move, think, or is life simply matter that has learned to listen? On some distant planet, perhaps something listens even now, a creature beneath alien skies, sensing its own existence, looking upward toward a faint, distant light that happens to be you. The thought humbles you. You realize that every star you've ever seen could be part of a reciprocal gaze. Somewhere out there, curiosity might look back. The cosmos isn't empty. it's reflective. Every photon that leaves Earth becomes a message, an unintentional signal, proof that you exist. You drift onward through this gallery of alien suns, their light blending softly into the dark. The deeper you go, the more you feel it, that sense that the universe is not cold, but alive with possibility. Each world a variation on a theme, each star a note in an endless chord. And as you move through them, the wonder settles gently into calm. You realize that even if you never find another Earth, it doesn't matter. The search itself, the act of looking, imagining, understanding, is its own form of life. Curiosity is the universe becoming aware of itself. You close your eyes, floating in the space between suns, and let that truth hum through you. Somewhere, beyond sight, light from 1,000 new worlds continues its journey, carrying with it the promise that discovery never truly ends. You glide onward, away from the warmth of suns and their orbiting worlds. The sky seems to grow more intricate as you drift. What looked like a scattering of stars begins to reveal a hidden pattern, long filaments of light, threads connecting galaxy to galaxy in subtle chains. You are beginning to see the cosmic web, the grand architecture of everything. From this vantage, you no longer see individual galaxies. You see structure, you see shape. Filaments stretch across the universe like gossamer strands, hundreds of millions of light years long, shimmering faintly with the glow of galaxies and gas. Between them lie vast voids, empty bubbles of darkness, where almost nothing resides. It looks fragile, but it is the strongest pattern there is, the skeleton of the cosmos itself. You drift along one of these filaments, tracing its luminous curve. Each glowing knot along the strand is a galaxy cluster, bound together by gravity and dark matter. Their light merges into soft golden rivers, flowing slowly through the black. The scale is incomprehensible, yet it feels strangely delicate, like frost forming on a window pane, or the branching of veins under skin. Astronomers discovered this vast pattern through observation and simulation, mapping galaxies like stars in a larger constellation. What they found astonished them. The universe is not random. It has a texture. Matter, guided by gravity and dark matter, organized itself into this immense web. You realize you are looking at a pattern that echoes the structure of neurons, lightning, tree roots, river deltas. The universe, at every scale, prefers the same geometry, connection. A curious fact: the largest known structures in the universe, the Sloan Great Wall, the Hercules, Corona Borealis Great Wall, stretch across billions of light years. Their vast filaments link clusters containing millions of galaxies. Yet beyond a certain scale, the pattern fades. Even the universe has its limits of connection, beyond which expansion smooths everything to calm. You move slowly through a node, a place where multiple filaments converge. The gravitational pull here feels palpable, a gentle tug from every direction. The gas between galaxies glows faintly, heated to millions of degrees, thin but luminous. It hums in X-rays, a silent plasma filling the spaces between worlds. You can sense the energy in it, slow, ancient, tireless. As you pass through the luminous intersection, you notice how the filaments bend and weave. They are not straight lines but graceful arcs, curving under the weight of invisible dark matter. It's as though space itself has tension, like a net stretched just enough to hold the shape of everything inside it. The stars, the galaxies, the dust, they are all caught in this web, each one vibrating subtly, part of a larger harmony. Scientists still wonder why the universe formed this way. Simulations suggest that small quantum fluctuations in the early cosmos, magnified by gravity, led to this intricate design. Those tiny imperfections, once random, became structure. It's remarkable to think that every filament, every galaxy, every star including the one that warms your world, exists because of minuscule ripples in the infant universe's energy. Imperfection, it seems, is the root of creation. You drift along the filament, and it feels alive beneath you, humming with hidden motion. Gas and dust flow slowly toward clusters, guided by gravity like rivers seeking the sea. Along the way, new galaxies form, small and bright, drawn by the same silent pull. Even on this unimaginable scale, the universe moves with rhythm. You realize that what you see here is not static, it's evolving. Over billions of years, the filaments stretch, the voids widen, and clusters drift apart. Dark energy continues its quiet push, reshaping the web into something more diffuse. In the far future, these cosmic threads may thin until the connections dissolve, leaving isolated islands of galaxies floating alone in the dark. But for now, the pattern still holds, intricate and beautiful, a living network of light. You think about how similar it all feels to something within you, the tangled connections of the human brain. Neurons fire, paths form, signals travel, building thought from complexity. Perhaps the universe mirrors itself on every level, the mind of the cosmos reflected in the minds it creates. A strange symmetry between the largest structures and the smallest sparks of awareness. A quirky detail. Astronomers have compared computer maps of the cosmic web and microscopic images of neural networks. The resemblance is uncanny. Both display filaments connecting dense nodes. Both balance efficiency with redundancy. The ratio of matter density to volume, even, is astonishingly alike. The universe, it seems, might think in the same language it used to build itself. You glide along a thin filament, leading away from the node, and the view changes again. The density of galaxies decreases. The voids expand around you like dark oceans. You sense their immensity, regions so empty that a beam of light could travel for hundreds of millions of years before striking a single atom. Yet, paradoxically, these voids define the structure. Without emptiness, there would be no contrast, no form. Scientists sometimes call these spaces nothing, but even here, faint traces of matter remain, whispers of hydrogen, thin clouds of gas, wandering photons from ancient stars. The universe never truly reaches zero. Every emptiness holds something, even if it's only the faint memory of light. As you drift across the boundary between filament and void, you feel a soft shift, a change in pressure that isn't physical but perceptual. The stars grow sparse, their light dimmer, but the quiet deepens beautifully. It's like slipping from a symphony into the pause between notes. You imagine what it would be like to stand outside this structure, to see the entire cosmic web at once. It would look like a glowing lattice, filigree etched across infinity, delicate yet vast beyond comprehension. You realize that the structure you float through, is the closest thing the universe has to a body. The galaxies are its cells, dark matter, its bones, light, its bloodstream, and perhaps, just perhaps, consciousness, yours included, is the whisper of its awareness. Scientists still debate the limits of the web. Does it extend infinitely, repeating its pattern beyond the horizon of what we can observe? Or does it curve back upon itself, a closed network like a sphere of light? No one knows. The visible universe might be just one shimmering strand among countless others, woven into a fabric far larger than our imagination allows. You glide between two clusters, linked by a thin, glowing bridge. It stretches like silk across darkness, fragile but unbroken. You can feel the gravity balanced perfectly along its length, each side pulling just enough to hold the tension. It's a moment of pure harmony, a cosmic balance so perfect that it feels like peace itself. The farther you drift, the more you realize that nothing here is random. Every movement, every connection, every void serves a purpose. Even emptiness contributes to design. You understand now that the universe is not just vast, it is organized, not by intention, but by the simple, elegant rules of physics unfolding into complexity. You close your eyes and imagine the web shrinking down to the scale of your body, the atoms in your hands, the neural paths in your brain. You see the same geometry repeating endlessly, from the tiniest particles to the grandest galaxies. It feels like an affirmation whispered by the cosmos itself. Everything is connected. When you open your eyes again, the filaments fade gently into the dark, their glow dissolving into starlight. You are surrounded once more by quiet, suspended in the balance between structure and void. The web stretches endlessly around you, unseen but always there, a reminder that even across billions of light years, the universe holds itself together through invisible threads of gravity, light, and wonder. You drift along one of the filaments until it fades into the infinite, and something in the darkness begins to stir in your thoughts. You realize that for all the beauty you've seen, the stars, the galaxies, the web itself, there might still be more. Perhaps what you've witnessed is only one layer of a greater reality, one page in a vast book. You begin to sense the edges of something profound, the multiverse hypothesis, the idea that there may be countless universes beyond your own. The thought feels impossible, yet strangely natural. The cosmos has never been content with smallness. Every time you thought you'd found the boundary of existence, it expanded Earth to solar system to galaxy, galaxy to cluster, cluster to web. Perhaps now, even the universe itself is just another cell in a still larger structure. You imagine it not a void, but an ocean of universes, each a bubble of space-time expanding in its own direction. Some bubbles may be vast and smooth, others chaotic or curved. They might collide, merge, or drift apart forever. If your universe were one of these bubbles, its surface would be the horizon of reality, the place beyond which light and causality can never reach. And beyond that, more bubbles, more worlds, endlessly. Scientists call this idea the multiverse, and though it sounds like poetry, it's rooted in physics. In the inflationary model of the early universe, the Big Bang wasn't a single explosion but a process. Regions of space expanded at different rates. Some stopped expanding, forming universes like yours, while others continued, forever inflating. Out of that eternal inflation could come infinite realities, each with its own laws of nature, its own constants, its own versions of matter and time. You float within that idea, as if inside a dream, surrounded by endless spheres of light, each one a separate cosmos. Some might resemble yours, full of stars and life. Others could be strange beyond imagination. Universes where gravity repels instead of attracts, where atoms never form, where time runs backward or doesn't exist at all. You realize how vast that possibility truly is. If there are infinite universes, then somewhere, perhaps another version of you drifts through another sky, asking the same questions. Another, you might have taken a different path, made a different choice, become a slightly different soul. The thought doesn't frighten you, it comforts you. It means the universe is generous enough to allow every possibility to exist somewhere. A curious fact, quantum mechanics, that mysterious foundation of reality, hints at similar multiplicity. In the many worlds interpretation, every quantum event creates a branching of outcomes. Every decision, every movement of a particle, gives rise to parallel histories, universes splitting endlessly, each as real as the next. You might still be sitting at home in one. In another, you may never have been born. In yet another, the stars themselves might sing in colors unknown. You let the idea expand around you until it feels infinite. Each possibility, each reality, exists not in competition but in harmony, different notes in an eternal chord. You are one vibration among countless others, a melody played in one corner of a boundless song. You drift toward a faint shimmer ahead, a region where one universe might brush against another. You can't see it directly, but you sense the interference pattern, like ripples meeting on a pond. Some cosmologists think that if two universes ever collided, their contact would leave subtle imprints on the cosmic microwave background circular scars in the oldest light. None have been proven yet, but the possibility lingers, like a half-remembered dream. You imagine that meeting, two realities touching for an instant, trading whispers through gravity and radiation before parting again. Perhaps such collisions gave rise to galaxies, or altered the constants of physics. Maybe they happen all the time, unseen beyond the horizon of your cosmos. A quirky thought drifts through you. If there are infinite universes, there might also be infinite forms of beauty, colors you can't perceive, symmetries beyond geometry, even kinds of consciousness utterly unlike your own. Somewhere, perhaps, there is a world that never knew stars, yet still learned to dream. Somewhere else, thought itself might flow like wind, shaping matter without hands or eyes. You can't know these places, but you can imagine them, and imagination itself feels like a bridge. Each time you wander, your mind opens a small doorway, tiny perhaps, but enough to glimpse infinity. The multiverse becomes not just a theory of physics, but a meditation on possibility. Scientists still wonder how we could ever prove it. Some say the evidence may be forever beyond reach, trapped outside our observable universe. Others think quantum fluctuations, patterns in gravitational waves, or distortions in background radiation might one day reveal hints. But even without proof, the idea endures, because it satisfies a truth we already feel. Reality has no edge. You think of soap bubbles clustering in air, each one delicate, luminous, and brief. If you could step outside, you'd see them reflecting each other's light, tiny universes within universes. It's not a hierarchy, but a continuum, each bubble creating its own physics, each one complete, yet connected through the same underlying space. You turn slowly, trying to picture what lies beyond your cosmic horizon. There's nothing to see, but you can feel it, the sense that something continues, just beyond reach. You realize that boundaries are illusions, conveniences for minds built to measure. The universe does not stop, it only changes its language. A curious whisper in your thoughts. What if these universes aren't separate at all, but layered? Perhaps they overlap in dimensions beyond your perception, sharing space the way radio signals share air. Right now, countless realities might flow through you, invisible and silent, each following its own melody. If you could tune your senses differently, you might hear them all at once, a chorus of existence singing softly across infinity. The idea makes you feel weightless and small and eternal all at once. You see now that you are not merely in the universe, you are one expression of it, a ripple in an infinite sea, conscious for a moment, reflecting the whole in your awareness. You let the thought settle, as gentle as breath. Perhaps the multiverse isn't about separation, but connection, the realization that reality's creativity is infinite, that being itself is abundant beyond measure. The cosmos doesn't repeat, it experiments. Every world, every atom, every moment is a unique variation, and all are necessary to the whole. You drift through that understanding, surrounded by invisible infinities, and it feels peaceful. You don't need to see them. Knowing they might exist is enough. Somewhere, light continues to rise. Somewhere, stars are being born. Somewhere, another version of you smiles at the same thought. And as you continue onward, you feel a quiet assurance that even when this universe ends, and it will, one day something else will begin. There will always be another dawn, another sky, another chance for awareness to look upward and whisper the same question: what lies beyond the stars? You drift farther still, beyond the shimmer of imagined neighboring worlds, back into the long quiet of your own. The galaxies stretch thinner here, fading into isolated islands of light across vast seas of darkness. The stars grow sparse. The silence deepens. You have arrived in a time that has not yet come, the far future, when the universe has aged beyond memory. Here, you begin to witness the fate of everything. At first, nothing seems different. Space looks the same, still beautiful, still full of distant fire. But the light you see now has traveled for trillions of years. The galaxies that sent it are no longer where they appear to be. Time has stretched them apart until their glow is little more than a whisper of what once was. The universe continues to expand, its fabric drawn thin by the gentle, unending push of dark energy. You look back toward what was once the Milky Way. It is no longer a spiral, no longer blue with young stars. Its arms have blurred and softened, its color turned to amber. Long ago, it merged with Andromeda, forming a single massive elliptical galaxy called Milkdromeda, its stars slower, older, redder. Most of the bright young suns have burned out, leaving only ancient red dwarfs and cooling embers. The sky above such a future Earth, if it still exists, would be almost empty. The familiar constellations gone, replaced by faint orange points scattered thinly across the night. The great clusters that once surrounded the Milky Way have drifted beyond visibility, carried away faster than light by the expansion of space. To any future observer, the universe would appear lonely and small. A curious fact, this process has already begun. Even now, galaxies farther than about 46 billion light-years are receding from us faster than light due to the stretching of space itself. Their light will never reach us. Every second, more of the universe slips beyond our horizon, unseen but not gone. It's as though the cosmos is slowly closing a curtain, not out of malice, but to let each region live its own quiet story. You drift through this thinning light and imagine time passing in waves. After a few trillion years, even the long-lived red dwarfs begin to fade. They cool and dim into black dwarfs, cold spheres of carbon, invisible in the dark. The last flickers of starlight vanish, and the universe becomes shadow again. Yet, even in that darkness, there is motion. White dwarfs collide and spark briefly, sending out one last flare before fading again. Black holes feed on the remnants of galaxies, their gravitational grip strong even when all else grows still. They merge, emitting gentle ripples of gravitational waves that travel endlessly through the expanding void. Scientists call this distant era the degenerate age, a time when all ordinary matter has cooled, condensed, or collapsed. The universe, then, is quiet, but not lifeless. Particles still move, quantum fluctuations still flicker, and gravity still binds invisible structures. The cosmic web remains, stretched beyond imagination, but intact. You drift past a lone black hole, one of the last. It spins slowly, surrounded by the faint glow of matter, still falling inward. It has swallowed suns, planets, perhaps entire civilizations, and now it rests, radiating faint heat through a process called Hawking radiation. Over unimaginable spans 10 circumflex, 100 years or more, it will evaporate completely, releasing its energy back into space as the gentlest warmth. Even black holes, those eternal giants, eventually dissolve into nothingness. You can feel that future quietness settling into you. The stars no longer shine, but the darkness isn't empty. It's full of memory. Every atom, every photon, every gravitational wave carries a trace of what once was. The story of creation doesn't end. It simply becomes harder to see. A quirky thought. Even in this cold, dark age, occasional miracles might still happen. Quantum fluctuations could nudge particles together, triggering rare collisions, brief flashes of light in an ocean of silence. The universe, even exhausted, might still dream. You glide through time until only diffuse radiation remains, stretched by expansion to wavelengths larger than galaxies. The temperature of space hovers near absolute zero, yet never quite reaches it. The cosmos cannot stop moving. It cannot completely freeze. Motion, however faint, endures. Scientists still wonder what will ultimately happen. Some propose that dark energy will continue its acceleration indefinitely until galaxies, atoms, and even space-time itself are torn apart in a big rip. Others suggest that as expansion slows and reverses, the universe could collapse again, a big crunch, perhaps giving birth to a new cycle of creation. Still, others imagine a gentle fade, the heat death, where everything becomes evenly spread, no gradients left to power, motion, or thought. Entropy would reach its maximum, and time itself would lose meaning. You realize that each ending is also a transformation. The Big Rip becomes a return to quantum foam. The Big Crunch could ignite a new Big Bang. Even heat death might give rise to fluctuation, a spark, a new bubble of space-time, another beginning. The universe, it seems, doesn't die. It simply changes its rhythm, trading one kind of motion for another. You picture that beyond the end of light, beyond the end of time, new universes budding like seeds from a sleeping root, each one unique, each one carrying traces of the old. Perhaps the constants differ slightly. Perhaps the geometry twists in new ways. Maybe some of those worlds will form stars again, and on some of those stars' planets, something will look up and wonder, what lies beyond? A deep calm settles over you. You see now that endings are not sad, they are necessary. Without endings, there can be no transformation. Even your own atoms are proof of that. Born from dying stars, they came together briefly to form you, and one day they will scatter again to make something else. You are part of the same cycle that governs galaxies and time itself. The future you drift through is vast and quiet, but it's not lonely. It's filled with the echo of everything that has ever been: the memory of light, the patience of gravity, the whisper of creation. You realize that the universe does not mourn its fading. It simply becomes more serene. You take one long, slow breath, though no air surrounds you. You feel as if you are inhaling the history of everything: the starlight, the dust, the silence. And as you exhale, you let go of the need for a beginning or an end. There is only motion, only change, only peace. You turn toward the dim horizon, where even the concept of horizon begins to dissolve. Somewhere, in the distance, new universes may already be forming, tiny bursts of possibility blooming in the dark. The cosmos continues, endless, patient, alive. You drift through that final quiet, no longer measuring time, no longer counting light. The fate of everything feels simple now. It all returns to calm. The stars go out, but the wonder remains. You drift through what feels like eternity, though the word no longer quite fits. Time has thinned, slowed, and stretched, until it's less a line and more a texture, a gentle hum, through which existence still whispers. The light is almost gone now, but something faint remains, a delicate shimmer scattered across infinity. You are surrounded by what could be called the memory of light. It's subtle, barely there, but once you notice it, you can't unsee it. Every particle of light that has ever existed leaves a trace, a residue, in the fabric of space. The photons from the first stars, the last sunsets, the ancient bursts of supernovae, all of them still travel, still move, still record. You realize that the universe, even in its silence, has a perfect memory. Each photon is a messenger, a tiny archive. It carries with it the story of where it came from, the temperature, the motion, the fingerprint of its birthplace. When you look at starlight, You're not seeing just brightness. You're seeing information. Every glimmer holds the chemical signature of its source, the motion of its star, the age of its journey. Light, more than anything else, is how the universe remembers itself. You move slowly through this pale, eternal glow, and the thought comforts you. Even as everything else fades, light refuses to be forgotten. The energy that once illuminated the cosmos now stretches across space as gentle waves, so long that they barely count as light anymore. Yet they persist, an ocean of ancient photons still wandering. A curious fact: when a photon leaves a star, it travels forever, unless it meets matter. It doesn't age the way you do. It experiences no time at all. From its own perspective, its creation and its arrival are the same instant. That means, in a strange way, all light is eternal. It never truly wasn't. You imagine what that must feel like, to exist in one unbroken now, to move endlessly and never grow old. For light, distance, and duration are illusions. The photons you see tonight left their stars millions or billions of years ago, yet for them, it has been no time at all. They are as young as when they began. You drift through a field of faint remnants, photons, that once belonged to the heart of stars. They scatter and dance like fireflies in slow motion. You wonder if one of these could have brushed Earth once, reflecting off oceans or clouds before continuing into the void. Even now, it might still carry a trace of your planet's light, traveling outward forever. A quirky detail: some photons emitted at the dawn of the universe may never be absorbed. They will wander eternally, stretched by the expansion of space until their energy becomes almost nothing. Yet, according to the laws of physics, they still exist. They are not gone. They are simply quieter. The universe holds onto every memory, even those too faint to notice. You realize that memory itself might be the universe's defining quality. Every particle, every field, every quantum fluctuation encodes its history in subtle ways. The spin of an electron, the direction of a magnetic field, the energy of a photon, all are tiny archives of everything that has ever happened. The cosmos doesn't forget. It simply changes how it remembers. You think of the night sky as a time machine. Every star you've ever looked at shows you the past. The nearest ones, a few years ago. The farthest, billions of years. Some may not even exist anymore, their light still crossing space long after their fire has gone out. To look at the sky is to see ghosts, not of death, but of endurance. Scientists call this look-back time. When telescopes gaze deep into the cosmos, they peer into ancient epochs, watching galaxies form, collide, and evolve across the ages. The James Webb Space Telescope, floating silently in darkness, captures light that began its journey near the dawn of creation. You realize that the universe's autobiography is written entirely in photons. You pass through the faint echo of one such beam, and for an instant, you feel as if you can see everything: the birth of a star, the pulse of a planet's orbit, the faint shadow of life blooming and fading. It's all there, encoded in wavelength and rhythm. The memory of light isn't just physical, it's emotional. It feels like warmth remembered, like the echo of laughter in an empty room. Scientists still wonder whether light truly lasts forever. Quantum theory suggests that photons might decay eventually, perhaps into even more subtle particles. But no one has ever observed it, and perhaps no one ever will. The universe is patient beyond measure, and its light may outlive everything else. You imagine collecting all that light, gathering it into one vast tapestry. It would be a portrait of the universe across time, bright where galaxies once thrived, dim where they faded, streaked with colors of birth and collapse. If you could read it, you'd find every story ever told written in radiance. The fires of suns, the quiet reflection of moons, the shimmer of oceans under alien skies. The thought moves you deeply. You begin to understand that light isn't merely illumination, it's intimacy. It connects everything that has ever been. Every photon you've ever seen has touched something else first, perhaps a star, a rock, a living eye. In that sense, light is always shared. It carries touch, presence, awareness across impossible distances. You think of your own life, the sunlight that has warmed your skin, the glow of lamps, the reflected glimmer of eyes meeting eyes. All of it, in the end, is part of this same memory of light. You have lived bathed in photons, billions of years old, part of a continuum of radiance that began before you and will continue long after. You turn in the dimness, and the faint glow around you seems to pulse, almost imperceptibly. Perhaps it's only your perception, but you feel as though the universe is breathing through its light, slow, vast, eternal. Even as expansion carries everything apart, these photons remain the messengers between worlds, binding what was to what will be. A single one brushes past you, invisible but real, crossing your path before continuing its endless journey. It will go on forever, carrying with it a tiny fragment of history, of everything that ever was. And in that moment, you understand that this is what immortality truly means, not living forever, but being remembered by the light. Every warmth, every reflection, every beam that ever touched you will continue outward, softer and softer, until it becomes part of the cosmic background itself. Nothing ever vanishes entirely, it only changes how it shines. You let the glow fade into the quiet again. The stars are almost gone, yet their memory fills the dark like perfume lingering after the candle has burned out. The universe, you realize, is still radiant even in its silence, even in its stillness. It remembers. You breathe softly, feeling that same memory in yourself, the warmth of existence, the faint, endless hum of being. You, too, are a trace of light moving through time, carrying everything you've touched forward into infinity. You drift through the dim expanse where time itself has become almost weightless. The glow of the cosmos is faint now, no longer a blaze of galaxies, but a scattered shimmer, soft and patient. You turn slowly, feeling gravity's distant tug from the great galactic core far behind you. It grows fainter with every moment. Ahead lies the long journey home, back toward the Milky Way, back toward the familiar curve of light you once called your sky. The path isn't marked, but you can sense it. The faint, dusty ribbon of your galaxy glows ahead, a swirl of silver mist, turning gently in the dark. You approach slowly, letting the pattern grow sharper until the familiar shape returns. A great spiral, luminous arms stretching across thousands of light years, every strand of it humming softly with motion. The closer you come, the more it feels like returning to memory. There's the pale sweep of the Orion Arm, the place where the sun drifts with its quiet companions. The stars seem warmer here, their light more personal, more immediate. You pass bright clusters, veiled nebulae, regions where new stars are still forming. The smell of cosmic dust feels familiar now, like rain returning to a long dry field. Somewhere within this turning sea of light lies your solar system, a small spark, orbiting an unassuming star. You glide closer, watching the faint glow of planets circle the sun, each one tracing its steady path. The warmth grows brighter, the light clearer, until you can almost feel it again on your skin. You slow your drift, suspended between planets, watching them move in perfect rhythm. Mercury, small and fast. Venus, bright and veiled. Earth, a pale blue glow wrapped in clouds and oceans. You linger on it, letting its delicate shimmer fill your mind. The sunlight reflecting off its atmosphere looks gentle, fragile, alive. You see the slow rotation of clouds, the dance of storms, the sparkle of polar ice. From here, Earth looks utterly calm, You can't hear the voices or the noise of cities. You can't see the movement of lives below. But you can feel them, all the small miracles happening each second. The opening of a flower, the fall of rain, the breath of someone standing under the same starlight you followed. The galaxy, for all its grandeur, still finds its meaning in the quiet persistence of life on a tiny world. A curious thought drifts through you. The atoms that form you, the water, the air, the light, all of it, has traveled a cosmic path. You have been dust in a nebula, iron in a star, carbon in a comet's tail. You have been recycled endlessly through time, through birth and death, through heat and silence. Every inhale you take on Earth is a continuation of the universe breathing. You gaze at the stars surrounding your home world. Many of them you've now seen from afar, their secret lives, their beginnings and endings, their quiet resilience. They look different now. They're not distant, they're family. You realize that every point of light in the sky is part of the same pattern, part of the same long story of motion and becoming. Scientists still wonder whether the universe will keep expanding forever, or whether some deeper law will call it back. But perhaps the question doesn't need answering. The beauty isn't in the conclusion, but in the continuity. Each particle, each beam of light, each orbit is part of an unending rhythm. You float above Earth a moment longer, watching night fall across one hemisphere, while dawn brightens another. City lights twinkle softly, oceans reflect the moon, clouds glow faintly with the color of sunlight turned gold. You remember the quiet sound of waves, the scent of rain, the warmth of morning air. The universe may be vast, but it feels closer now, folded gently around you. You begin to drift inward again, through the familiar warmth of your planet's atmosphere. The blue deepens into indigo, then softens into the grey of clouds. Below, the ground glimmers faintly in moonlight. You can almost feel the gravity again, gentle but insistent, drawing you home. You realize, as you descend through the calm air, that you have not simply traveled through space. You have traveled through understanding. You've followed the thread from the birth of light to the edge of time, and now you return to where it all began, with awareness, with stillness, with gratitude. As you near the quiet surface of the world, the stars above remain visible through a veil of atmosphere, their light blurred but constant. You can still hear them, not with your ears, but with something deeper, the hum of their distant burning, the slow rhythm of their orbits, the endless chorus of existence. And in that soundless harmony, you recognize something. It is the same rhythm as your breathing, the same pulse as your heartbeat. You are not separate from the stars. You never were. You are made of their remnants, carried on their light, sustained by their warmth. The universe does not surround you, it flows through you. You let that awareness settle into you like gentle gravity. The questions that once seemed enormous now feel like lullabies. Their mystery no longer something to solve, but to rest inside. The cosmos doesn't demand answers, it offers presence. The night deepens. You find yourself lying beneath the open sky again, the air cool, the stars bright above the horizon. You think of all you've seen, the nebulae, the dying giants, the invisible webs, the light older than memory, and it all feels near, woven together in the same quiet breath. You exhale slowly, feeling the weight of wonder give way to peace. The stars blur softly as your eyes grow heavy. The last thing you notice is their flickering, patient, distant, eternal. And now, as you lie beneath the sky, let everything you've seen fade gently into calm. Imagine the stars dimming, one by one, not vanishing, but softening into memory. Their light remains in you, quiet and kind. The vastness of space no longer feels cold. It feels like a blanket, endless, weightless, filled with warmth that isn't heat but understanding. The galaxies, the nebulae, The faraway worlds, they all hum quietly in rhythm with your own breathing. The questions that filled your mind, what lies beyond, what began it all, are no longer questions. They are melodies, gentle and slow, meant not to be answered, but to be heard. The universe isn't asking you to reach farther. It's inviting you to rest within it. Let your thoughts drift like dust in starlight. Let every breath slow. Feel the gravity of your body holding you, anchoring you to this small, precious world. Above you, light that began its journey before human history still falls softly through the air, touching your skin, reminding you that you belong. If you listen closely, you can almost hear it, the faint whisper of creation still resonating through time. It's the same sound that has always been there, in the silence before dawn, in the pulse beneath your ribs, in the hush of the sleeping earth. And as your breathing deepens, you realize there is no edge to this calm. You are part of it, woven into the fabric of night, luminous in your own quiet way. The stars do not look down upon you, they shine through you. Rest now, traveler of light. The cosmos keeps its gentle watch. Everything is connected. Everything is at peace. Sweet dreams.